Publish Industry India Private Limited is a 16-year-old publication house based in Pune, parent to Efficient Manufacturing magazine. EM is a leading creative magazine which aims not only to top decision makers but also engineers and technocrats from the manufacturing network. Its readers are spread across automotive, machine tools, aerospace, electrical and electronics, power and energy, material handling, logistics, general machinery, and steel and mining sectors, making it the most sought after magazine in the sector. As you all know, the Indian automotive industry is the third largest in the world and stands as one of the strongest pillars in the Indian manufacturing sector. With this backdrop, we are here to deliberate on this fascinating and ever-evolving sector. To formally commence our summit, let us now grace the event with a traditional lamp lighting ceremony. This ceremony symbolizes the dispelling of darkness and the ushering in of knowledge and enlightenment. Please join me in welcoming Mr. Arun Bhardwaj, Editorial Director of Efficient Manufacturing magazine, Mr. Ashwani Jotshi, ex-Regional Head, ECMA, Dr. Sreyas Vidyasagar, VP and Global Head, Industrial Heavy Machinery, Practice, Tata Technologies, Mr. Shailendra Goswami, Chairman and Managing Director, Pushkaraj Group, and Mr. Abhijit Kumbhar, Deputy General Manager, ARAI. I request you all to please come on stage and grace the event with your presence. Music. Thank you, dignitaries, for gracing the event with your presence today. I now request Mr. Ashwani Jotshi to address the gathering with his welcome note.
Good morning, everyone. I am Ashwani Jotshi. Let me just give briefly introduce that I was in ACMA. Now I have superannuated from ACMA. And I am now using all my learning age experience and supporting such kind of activity. Anyway, good morning once again to everyone. We have these distinguished speakers here. Dr. Sreyas Vidyasagar, VP and Global Head, Industrial Heavy Machinery, Practice, Tata Technologies. Mr. Shailendra Goswami, Chairman and Managing Director, Pushkaraj Group. Mr. Abhijit Kumbhar, Deputy GM ARAI, Mr. Arun Bhardwaj, Editorial Director, Efficient Manufacturing Magazine. We have Mr. Dhiraj Bhalerao also, who is Director, Publish India, and many other speakers which we have from Eton Bosch, and those some of them are going to join. Friends, ladies and gentlemen, I have great pleasure to welcome you all to this 5th edition of International Automotive Manufacturing Summit. It is my privilege to welcome you all once again. As we all know, the auto sector in our country is a glamorous sector, if I may say so, and this is the one who contributes very handsomely in the GDP of this country. At this juncture, we are experiencing, transforming through various new technologies and policies, and especially we know this time, current period, government's push is on electric vehicle. So in today's conference, we are going to have knowledge and experience sharing from all our speakers in the area of technology, if I may say, and certainly the lot of uncertainty and disruption in supply chain which we are experiencing. The kind of speakers we have today, I have no doubt that we are going to have a very, very exciting session. We will be enriched with their knowledge and learning, and we look forward. Because of the climate, which is also one of the key for our industry, we are talking about the carbon neutrality. And this climate has, in fact, stopped many of the participants who couldn't join us today. So I will not take much time because we have already behind the schedule. I once again welcome everyone who has joined today, and I think many of people who are stuck in traffic will also join. And we will be having a very, very exciting session today. So with this, I will close my welcome address and welcome you all. Thank you very much for joining. Thank you.
Thank you, Mr. Jotshi. With this, we are now ready to proceed with today's presentations and keynote addresses. Please note that we will be taking few questions at the end of each presentation. We begin the day with a keynote address by Mr. Shailendra Goswami, who is a chairman and managing director at Pushkaraj Group. He is also associated as an advisor with Aditya Enterprises and Tanvi Enterprises. He has worked in corporate sector for 15 years and started his own venture in the year 1992 and has spent almost 31 years in business. He'll be talking on the topic of embracing Industry 5.0, pioneering the future of innovation. Let's invite him on the stage with a round of applause.
This is okay? Yeah. Good morning, everyone. First of all, thank you, Arun, for giving me this opportunity to attend the second edition as far as I'm concerned. Although you are on the 5th one, the first one which I attended was in 2022, and now this one is the second one. Last time also I had spoken about the advanced techniques in manufacturing, and today I'm touching the subject which is very, very dear to most of the manufacturers, is migration on various generations of technology, and people have been talking about this for a long time. Industry 4.0, but then these days we are speaking about Industry 5.0. Now, what is the genesis of all this on manufacturing? If I may recall, now practically I'm clocking 50 years as far as professionalism is concerned. So when I started my professional career in manufacturing in a diesel engine plant, 1978 to be precise, at that time we virtually had everything manual. And we used to achieve certain targets based on the human efficiency rather than the machine efficiency, or for that matter on the processes, on number of hours and things like that. So it was a sort of a manual mechanical integration which was there. At that time, the requirements were also not to that extent the way we have it today. We had an ecosystem which was restricted to maybe India as such. We were not there on the global map. Although we were there, we were not there predominantly. Nobody recognized India as a manufacturing hub. And to tell you frankly, at that time, this need was not felt. And it went on for a number of years till we were struck with COVID. In COVID, many things changed, and one of such things which changed was manufacturing and the inputs required for manufacturing to improve productivity. And this is where I have been talking about Industry 4.0 or migrating to Industry 4.0 for the last 8 to 10 years, but there were hardly any takers. Meaning in those couple of years, I was doing it as an sort of an advisor to companies in improving their productivity or manufacturing. So virtually I had no stakes, therefore I could not implement those decisions. But then, unfortunate part, COVID happened, and then we realized that the labor suddenly disappeared, and production, forget about the productivity part of it, the production suffered. And in those situations, people realized that had they migrated to Industry 4.0, at least they could have salvaged a little bit, because machines would have performed certain jobs which otherwise labor were doing it, semi-skilled, skilled, or whatever it is. But as COVID struck, thereafter people were rushing on their agenda on development of processes, on development of generations of manufacturing, and that is where Industry 4.0 really took off. So I would say that there were people, if I don't want to get into the numbers or percentages, but then there were people who were already doing it, but then the number of people or number of companies migrating to Industry 4.0 really started taking its pace after COVID. The second aspect which was there was we were basically an inward-looking society. We were never an outward-looking society. When we say inward-looking, we were very, very satisfied. At least if I talk about Pune, if I get business from Telco or Bajaj, I was okay with that. But today, I don't think that is the kind of a mindset that we have it. So we started looking outwards. Basically, people pushed us to look at the global marketplace as something which everyone should look at. And that is where, when global perspective comes into picture, every manufacturer had to think about not only productivity, but scalability, and scalability with the adequate amount of quality and reliability. Because the terms of sale also went up in automotive. We as a buyer are asking for 5 years or 5,000 kilometers as a warranty. So naturally, when we are requiring those many numbers with that kind of a warranty, everyone is looking at the process. So when we do not sell in marketing, I always used to say that look in manufacturing. So never people understood. Once we started looking into manufacturing, marketing started having very, very easy access into the marketplace, because we started delivering those products to the requirements of the customers. So when we came to know that we in India as manufacturers can certainly sustain global demand or can look at global demand, and the manufacturing went up like that, because I've seen all these generations happening, and I have seen the way people have treated us globally. Because I operate a global network in 16 countries for demands and products and services. So I know how people used to treat me earlier, 20 years ago, and how today we get red carpets. Meaning After China plus one, again, things went up quite drastically as far as manufacturing and locations are concerned. So very recently, last year, I spoke in Vietnam about China plus one strategy and why people should look at India as a manufacturing hub. Because I thought that I had a recipe here in Indian manufacturing ecosystem where we could project India as a manufacturing hub. And today we can absorb any kind of RFQ coming from wherever and deliver. Not only on design development, but also on manufacturing. I was discussing with a couple of our colleagues here. Yes, there are areas where we cannot compete with China. Like for example, semiconductors, where the investments required are very, very, very high. But then the government has proactively supported 3 big ventures, and last month itself there are 3 ventures which have been signed, and we would like to be totally captive, or for that matter self-reliant as far as semiconductor manufacturing is concerned. And which is where I think it takes us in a sort of a leapfrog jump that we are taking as far as manufacturing is concerned. So Make in India initiative, which started in 2014, really taught us on making it in India and selling anywhere. But at that time, the IP part of it was not included in that. And when the policy of Atmanirbhar was announced, at that time, we started looking at even the designs part of it. So maybe earlier we were doing the collaborations with multinationals, but then we were taking their IP product and then inducting into our system and then making it in India. But today, we are trying to dilute even that IP which was coming from outside, and we are trying to create our own IP so that we become completely Atmanirbhar. How did this come about? This came about because of the complete geopolitical system which is in mess. Today, nobody knows which country is loyal to whom. And if at all we want to go in that economy scale, which our government has been all along saying that we are in the first 5, we would like to be in the first 3, etc. So the dependency on someone else will certainly kill our prospects of getting into that 3rd place or achieving that 5 trillion or $10 trillion economy. Now, having said all these factors, if you really look at them, that China's involvement or whatever you may say, that people have been blaming them for the COVID debacle, but then there are countries who have taken principled decision that they won't look at China as a source of manufacturing, which otherwise virtually the manufacturing basis from Europe and America had virtually shifted to China. Meaning I have visited Chinese companies several times. I know for sure we are 20 years behind them as far as manufacturing is concerned, but then certainly in those conditions we were 20 years behind. But if we really make an effort, proactive effort, I think we'll catch up with them in another 5 to 10 years time. But we still will require those 10 years. Let me remind you, because what they did was a pioneering activity, and nobody can really scale up the operations the way they did it. And there was a single-minded commitment on the workforce, on the companies, on the government, and the policies were framed like that, so that happened. But then today, I think we have a similar proactive government, policies, strategies, companies, workforce, and also the demand. So everything is very, very positive and in place. So what prevents us from getting into that mold is something which is very, very important. And having understood this particular background, then naturally we are trying to look at every avenue, whether it is sustainability, whether it is productivity, whether it is scalability, or whether it is global perspective or outward looking markets. We want to reach global. Everyone is traveling. So many people are, whenever we are asking for such seminars, I was trying to find some people for honoring as a chief guest and things like that. Most of the people are traveling. And why they are traveling? Not for fun. They're traveling because people have been inviting them to do collaborations. People have been inviting them to do business. And I'm no exception in that. At this age also, I have to travel roughly around 120, 130 days overseas. Go around the world because they require us and we have to give it. Now, once we realize that we have to give it, how do we give it? We cannot be having a status quo, or for that matter, a position where we do not want to change. We cannot be satisfied on what we are doing. So in Japanese, we always say there is a kaizen, that incremental learning has got to be there. So today, whatever we are there, like any contract that we are doing with automotive manufacturers, there is a YOY clause, year-on-year reduction. Well, as an engineer, we never understood that. How can we keep on offering every year 5% reduction? But then, last 32 years of my experience, I have been involved in that kind of an ecosystem where we have been able to offer. Which means what? We are improving on something else to offer that. People will put down economic terms that inflation itself is 6 to 9%. How can we come down by 5%? But then ways and means are evolved, and today a common middle class person can afford a passenger car. How he is doing that? Earlier, I remember in my third year of engineering, I could buy first my bicycle. Till such time, we used to walk or we used to take bus or something like that. But today, I think in colleges, at 11th standard itself, somebody has a key to his motorbike or something like that. So all these things have got to be understood. But yes, we cannot take responsibility for all these things. We have to take responsibility as manufacturers on certain things, that we do production as per the guidelines or as per the best efficiencies which are there in the marketplace or around globally available. And that is where the topic which I am touching today, that embracing Industry 5.0, pioneering the future of innovation, which is going to really take us to a level which will be absolutely a level playing field for most of our manufacturers compared to all the other global manufacturers. And once we achieve these kind of manufacturing standards, I think on quality we have already attained quite good IATF or QS or whatever, those standards are there. I think most of us qualify on that. But then on manufacturing, also on the generations part of it, from 4.0, we have to get into 5.0. What is 5.0? From first generation to fourth generation, we started eliminating human interference. And on Industry 4.0, virtually, we talked about cyber-physical machines talking to machines. And then we realized we are stuck with creativity, innovation, and intuition, which comes only from humans. So a process which is designed by human or a tool which is designed by humans cannot become a reason for replacement of a human being. That is a basic philosophy as far as Industry 5.0 is concerned. So we have covered a complete full circle, that we started with the manual thing, we went into a complete mechanized, automated world, and then again, we are introducing that manual thing into the system. That's how the complete ecosystem is complete. So let me just run through a couple of notes which I have prepared on that with this little background so that the context is understood very well. Industry 4.0 was marked by the integration of digital technologies, automation, and the Internet of Things into our manufacturing processes. Today, we stand on the cusp of Industry 5.0. Although not many people are talking about Industry 5.0, because whenever I'm sitting with some people, they say that, look here guys, we haven't matured as far as 4.0 is concerned. Where is the question of talking 5.0? It's the same way when we were at Euro 4, we were thinking of going to Euro 5, and then we leapfrogged directly to Euro 6, we avoided Euro 5. It's the same way this manufacturing is going to come, because we have to work in a real-time situation. By the time you master your Industry 4.0, world would have gone to 6.0, who knows? So we have to be keeping pace with that. So today's requirement has jumped from 4.0 to 5.0 very quickly. 4.0 did not get enough time to mature. So we may have to leave it half matured and then get into 5.0. Today we stand on the cusp of Industry 5.0, a paradigm shift that goes beyond the mere digitization of production process and instead focuses on integration of humans and machines in collaborative and symbiotic relationship, which is what I said, that without humans, we designed that entire system, how can we be replaced? So basic fundamental hypothesis is to be questioned, and that's where I personally feel most of the people who have invented all these techniques, they realized it. Okay, that how could we just walked out of that system which we created? And this has deficiencies in following manners, which we'll just run through them. In Industry 5.0, the human touch and creativity are not just valued, they are indispensable. As we embark on this journey of innovation, we must recognize that technology should be a tool that empowers us, not a force that replaces us. The point which I have been highlighting again and again, meaning I am the creator and nobody can wash me out. It's not an ego issue, but it's a decision making or it's a strategy by which we excel. Why an interference is required? Because that will ultimately improve the system. Not because I'm egoistic that how can I go out, nothing like that. It is about fostering a harmonious coexistence between man and machine. Like we always use this word that we have to coexist in COVID times, that we have to learn to coexist with the disease and work, both together. In the same manner, what we are saying is that harmonious coexistence between man and machine has got to be there. The essence of Industry 5.0 lies in the convergence of cutting-edge technologies such as AI, artificial intelligence, robotics, augmented reality, with the unique qualities of human intuition, which is what I am saying again and again, creativity and adaptability. The machines want program, they don't adapt. But human brain certainly can adapt on real-time basis with the happenings around us, because things keep happening and we cannot forecast everything and program it accordingly. Of course, we can perfect it, but we cannot be 100% there. It is about leveraging the strengths of both worlds to create solutions that are not only efficient, but also sustainable and humane. Again, this sustainable word is being tossed around many times by many people, and I think we haven't done much on that, but then there is a need to even look at it. This paradigm shift is not without its challenges. When we say that we have to resort to a technology, we have to create an interface and go into that, it is not very easy. It demands a re-evaluation of our educational system. So I'm going down to the basic first principle, is that if at all I have to induct all these things, I have to have resources. Those resources will come from where? They will come from academic institutions or the educational system. Workforce skills. There are already some number of workforces which are available with us, and the organization structures. As leaders in our respective fields, it is our responsibility to guide this transition thoughtfully and inclusively. I cannot say that I have instituted a new technology, a new system, so those many people go away. No. We have to be an inclusive society, especially in India. We are more socially oriented. So we cannot create an automation by which 600 million people will go out of job. There will be chaos, governments will fall. That is not something which we have to aim at. We must invest in reskilling and upskilling. Reskilling for the people who do not have it, and upskilling for the people who are at a certain level, raise them up to a level where we could use them, our workforce, ensuring that no one is left behind in this technological revolution. Mind you, this is very, very important. The moment you start talking about something which will eliminate something, the proposal doesn't go forward. Because there are other responsibilities. Fine, we are a profit center. We are supposed to make profit when we are in business, but we also have a social responsibility. If I have 3,000 people working in a plant, I cannot just say tomorrow that I'm implementing, like today people have been talking, that we introduce ChatGPT or AI into this and then we'll dispense off with 1,000 people. That is not going to happen. Because this question is posed to me several places in several events, is that tomorrow AI's induction, how many people will remain? I said, no, everyone will remain as they are. Last 30 years, we have seen evolution of technology, but not many people have been unemployed only because of induction of technology. Yes, the reason for unemployment have been several. We will have to evaluate them with respect to those many reasoning there. Because of technology, people have become unemployed. There are very, very few cases on that. Furthermore, Industry 5.0 presents unparalleled opportunities for innovation, entrepreneurship and economic growth, which is what we are aiming at. Today, everyone talks about innovations, everyone talks about economic growth. We are trying to reach a particular world order, third place or something like that. And in that, if we don't fall in line, then we will not be able to get into that. By embracing this evolution, we position ourselves at the forefront of new industrial revolution that promises to enhance productivity, optimize resource utilization, and create a more connected and resilient world. Ultimately, we are taking into account every element which is there in that ecosystem and trying to bring them up, not only one technological input because of which something will rise. Along with that, we have to make others also rise, then only we will sustain. We always say like that. If at all we have to have a structure, we have to have a pyramid structure. We always say, we cannot sustain unless we have that kind of a structure. And therefore, it has to be an inclusive word, meaning a couple of words which I have used, I think they should really tell you everything about it. So in conclusion, let us approach Industry 5.0 with a spirit of collaboration and open-mindedness. Just because I'm egoistic about technology, I should not go ahead and do that. We have to evaluate. There could be some industries who may not be ready to accept that. There could be some systems or there could be some products or services. They may not fall under the domain of Industry 5.0. Let us not be insistent upon doing that. There could be other means of doing it. Together, we can harness the potential of technology to address global challenges, drive economic progress, and improve the quality of life for people around the world. As we navigate this uncharted territory, let us be guided by the principles of ethics, sustainability, and inclusivity. I'm coming back to these three words again and again, because most of the times, the failures of technology have happened because either of these three things have been neglected. We cannot take only one stand. We have to take a complete inclusive and a complete ecosystem as a problem and then develop that. Thank you for your attention. I hope I was able to convey 2 cents from my side. If you have any questions, I would be glad to answer them. Can I take them?
Yes, yes.
Yeah. Yeah, please. I know Shrikant.
How are you doing?
I'm fine, thank you.
Thank you so much. It's really an eye-opener on a few points. I mean, we have been discussing stuff. When you say we have to have a collaborative approach, I just have a small curiosity, which probably we discussed in our last interactions also on different platforms and forums. It's that the entire automotive ecosystem is huge. Now, if we fragment it sector-wise or industry-wise, there are many setups that are lying idle. And instead of coming together, doing something, identifying they are running at what capacity, what is the spare capacity, and how we can leverage their potential to the overall requirements of the automotive market. What I have been seeing in my experience last 18 plus years, particularly electronics industry, is people come up with new plants, new setups, new lines, and the older ones, either they keep on lying idle or they have to be disposed of. So I think somewhere, is it not a need that we come together and make a consortium, identify such, at least we could start with our Western region, because we are automotive prone. So that is just my question. Should we be doing that, or the way we are going ahead already, you know, putting up new lines and then setting up new spaces instead of leveraging the existing ones? Yeah. Because that is going to definitely affect the overall economy of the country. This is number one. Another one, you mentioned that we will not be able to compete with China. But then you also said that we are improvising, we are taking it up proactively. But don't you feel that the difference in the structure of the government plays a major and important role there?
Yeah. Okay, fine. I'll answer your second question first because that's quite easy. You may sit down. Yeah. China was a socialist government. So if the president says, look here, you look there. As simple as that. If you have traveled in Shanghai, from Shanghai airport to reaching my particular hotel, I never had any bends. The road was straight, 40 kilometers. Why that could happen? Because there are no NGOs or there are no environmentalists who will come and oppose. Because nobody can oppose the government. If they oppose, they know what will happen. So if the road has to be straight, it goes straight. So that was the kind of a culture in which China really got developed themselves. Of course, whether that is right policy or wrong is something else. Because they don't carry the thread or the fragment of democracy with them. They are more of a dictators there. But then the governments or the countries don't run on dictatorship. We believe we are the largest democracy and every decision has to be weighed out. So we have environmentalists, we have NGOs, we have so many activists through whom we have to go, and that is how we progressed the way we have progressed. But if you really see, I always compare China and India on two fronts. China is very good on high volume, low tech, whereas India is very good on high tech, low volume.
I agree.
You get into any of these things. If we have to really invent a diesel engine or we have to invent a compressor or things like that, we will do so very easily in India. But the Chinese, they will easily clone it and then mass produce it. They are very good in toys or they are very good in certain things. But whatever they do, they would like to do it on a mass scale because scalability is their very, very strong point. I have visited their plants, automotive plants, tier 1 for bearings. Their minimum MOQ is 1 million pieces per day.
I agree.
Now, all put together, our bearing manufacturers will not be able to produce 1 million per day in India because that requirement was not there. So please understand my preamble in which I have said that we have become global players today. Once we become global players, there is a mandate that they are looking at India as a manufacturing hub, and there is so much of a demand which has got to be catered to. So what is left for us is only to match up that capacity. And we have the talent, we have the intellect, we have the desire or inclination to do that. And now the additional factor for the last couple of years is the government. Government is proactive. They have been taking very, very proactive decisions. They are supporting MSMEs, which is 55% of the total manufacturing GDP that does. So if we say that 25% is the contribution in GDP of manufacturing, which is going to be, of that 55% comes from MSMEs. And now for MSMEs in COVID, you have seen how many packages were declared because they wanted MSMEs to survive, therefore the manufacturing has to survive. So I think we have to understand that any of such things which have gone to a particular level, to achieve that particular level, we will take time. That is where I said we might do it in 5 years, so we might be able to do it 10 years, but we are going to do it. We are capable of doing it, and we will match every sector. Today, even the most advanced country like America could not match what China did. So forget, meaning their economies are running into 30, 40 trillion dollars, whereas we are just struggling at 3 trillion or 5 trillion. So money is not everything. It is the time, intent, and the way the entire world focused on China. So today when we are talking about China plus one strategy, anything other than China, that is where the Vietnams are coming, that is where the India is coming, that is where the erstwhile East European countries are coming, that is where South Americans are coming, Mexico, Brazil, and other places. Meaning you won't imagine a country like Poland, we never heard of it. Czechoslovakia, we never heard of it. But I have visited these countries on their manufacturing setup, they have gone up tremendously up. So
we are already better than China because we have been able to come through wherever we are despite all of these concerns.
Correct.
Thank you so much.
We can do that.
I think you addressed it.
Answer your first question. Synergy has to be there. Synergy has got to be there. And synergies get built up only amongst equals as far as the technology is concerned, because it requires money. An MSME may not have the kind of money which is required to be invested the way maybe a large company can invest. That is where they set up their facilities. But I have seen today, at least, most of the major OEMs, they would like to focus on their products rather than getting into the smaller these things. So they are giving it out to the MSMEs, most of the production responsibilities. What is happening at the major OEM places, I think Dr. Vidyasagar will corroborate with me, is assembly, testing, and quality this thing. But the componentry is coming from ACMA, the total setup that we have it, which is pretty large, and which is where I said that 55% of the manufacturing contribution is going to MSMEs. That means there is a synergy. Yes, there could be cases where, as I said, which could be very, very specific, which will require high capital intensive investments and things like that, where somebody may not be able to do it. But I have seen big OEMs investing money, that kind of a money in a smaller setup, and telling them okay, that I will invest in your place, you supply it to me, and then on a regular basis in ordering, they cover that investment. So these things, these models are there, of course. As you go along, as you travel with many people, you will understand that most of these people have been surviving because of the collaborations with the OEMs and then tier ones and then the tier twos. So most of the tier ones and tier twos today in the present situation are at least happy with the way the demand is coming from the OEMs, and then ultimately it is getting percolated because their capacities are also full. I have seen the tier ones setting up 10 plants, 11 plants for Tatas in different zones, in different territories as far as India is concerned. I think Bhalerao is one of them.
I agree.
Yeah, yeah.
I agree.
I hope
Thank
I
you.
was able to answer.
Yeah, but I think this seems to be, I didn't realize before I asked this question to you, but this seems to be a larger and difficult question to be able to address, but you did a good job. Thank you so much.
Thank you. Thank you very much.
For now, I'm happy.
Thank you.
Thank you.
Anybody else? Thank you very much. Thank you very much.
Thank you, Mr. Goswami, for sharing your insights with us today. It was truly very inspiring. I would now like to invite Mr. Arun Bhardwaj on the stage. I would now like to invite Mr. Arun Bhardwaj on the stage to felicitate Mr. Goswami for his presentation today.
He's always mentoring us and grace his presence for all our functions. Thank you. Thank you very much.
Before we go ahead, I'd like to make a quick announcement. Unfortunately, Mr. Sunil Kumar Tiwari, who is going to be our keynote speaker for today, had to cancel and cannot make it to the event due to some unforeseen circumstances. But moving on, we have a special address which will be delivered by Dr. Sreyas Vidyasagar, who is a VP and Global Head Industrial Heavy Machinery Practice at Tata Technologies. He has a strong academic foundation in mechanical engineering, operations management, and an executive MBA from the Indian School of Business. In his address today, he will talk on the emerging trends in manufacturing and the digital elements that are incisively shaping and influencing the contours of manufacturing. Let's invite him on the stage with a round of applause.
There you go. All right, very good morning. Thank you, Arun, for inviting me today to present some thoughts in front of this august audience. And I'm really hoping that, after Mr. Goswami's really mind-blowing address, I'll be able to do justice to what I am doing. And then when you are saying, sir, a lot of things basically I thought we'll build on. And so I hope we'll be able to see some correlations over there. So from Tata Technology, we are part of the Tata Group, and Tata Group needs no introduction. We have been in the industry as Tata Technologies for about 30 years now, close to the same, my experience is. We are about $500 million size, slightly bigger, and about 13,000 engineers. And we only cater to 3 sectors: auto, aero, and then industrial. And I take care of the industrial. And so that's a so we believe in the meter wide and mile deep strategy. And so we don't want to be everything to everybody and something to somebody. So from Tata Technologies, and if you see the product as a life cycle, it typically goes through 3 swim lanes. It starts with concept, which goes through the go-to-market swim lane. And then once the concept is taken to production readiness, then the manufacturing life cycle begins. And traditionally, there are 2 things, the traditional manufacturing and now the Industry 4.0, and still we have not started to talk about 5, but 4.0. And then once the product hits the market, then comes the aftermarket services. And of course, there are a lot of digital solutions that has been developed by the industry. Also, we as part of it, we have crystallized the knowledge, learnings that we have had, and then made them into digital tools. So, which kind of segues to today's discussion. That I want to touch upon 2 things. While from the trends that have started in the manufacturing industry, there are whole bit. I want to pick one trend and then dwell a little deeper into it, but also talk about what are some of the concerns that the industry is going through, and then try to show some case studies which kind of bridges these gaps. And that's basically what my next 20 to 25 minutes are. So we will take questions at the end. I might not be completely aware, but if I don't have an answer, I will get back to you. I promise that. Before I start, let me tell an interesting story that happened about close to now 2 years back. So one of the OEMs had invited us for a digital solution. So their situation was this: that they are a mining manufacturer. They build 40-ton plus mining trucks, and so this basically was for a 100-tonner body. The setup was such that there are 2 stations, and it is both robo activated. One station, while the robo does the welding, the other station, the operators does the transition points, like the corners basically, because the robo was not capable or designed to actually do all those corner stuff. So the plant manager who came to us basically said that the robo welding part is good, but then we are not very sure of the part where the manual welding is happening, and we need a digital solution wherein the checking of those corners that needs to be replaced by a digital solution. That was the ask. And so we went as a team, and then we saw what the current process was. So once the welding is completed, then it goes to this inspection station, and then an operator comes in with non-destructive testing tools, and then goes around checking, and then wherever there is a crack or imperfect weld, then he would put a mark around in a chalk, right? And then it will go to the next station where they would gouge it, and then they would do the welding. So now the plant manager's request was, I want to eliminate this guy, and then I want this. I don't know if he is checking everything, so digital solution should ensure that checking happens 100%. I said, okay, fine. And then so we proposed a solution where we extended reach Kobo mounted on an AGV, and then we will have to put an industrial camera on the stuff. So you get AGV moves back and forth, and then so you get two-dimensional movement there, and then the Kobo gives you the y-axis. So you have 3 axes plus, of course, the the arm over there, so you're able to cover. And then the industrial camera feeds back to machine vision system, pre-trained, trained, and then it is going to identify which are the areas where the rework needs to happen. So this is basically what we sell. And then there was a lot of back and forth about, will this work? Are there other things? All sorts of stuff. And so we showed a lot of cases. And the standard selling process. So those of you who are in part of the services, you understand what we go through, right? And then came the clincher. So the ask was that the operator who does this checking, so we pay 3 lakh rupees annually, contractor. So I want the system 1 year payback, and therefore it should be within 3 lakh rupees. The camera that I was actually planning to mount itself was about 2.5 lakh rupees. Forget about the AGV and the Kobo and the engineering time and all that stuff, right? Obviously that discussion did not go too well because we could not take that level of a cut to provide a solution. And so, which basically is what I want to touch upon today in terms of the thought process, right? So as Mr. Goswami rightly mentioned, the COVID time basically gave a jump start to digitization. So what a CIO could not do for last 20 years, those 6 months basically made a change. And then, it was proved that, things could be done outside. It could be digital, made a big impact. However, the thought still is, it's too expensive, right? I can still put a guy and I can still get something done. So why do we want to invest this level of stuff? So I kind of was remembering, when I bought my sister her first laptop long time back, not laptop actually, it was a desktop computer. In today's terms, it was almost 3.5 lakh rupees. Now today for 2025, maybe 30,000 rupees, you get a beautiful, extremely good capability laptop as compared to what we purchased at that time. Technology changes, but changing taking that technology as a cost and then trying to make the decisions is something that we need to think about, right? And then the second question of what if we choose wrong? There are so many technologies out there. How to know what it is? Is there some easy, quick and dirty way of doing this thing? So I'll show you some examples of how we can do that. Then the major pitfall that I see is this: replicate the current process from the digital assets that you are bringing in, right? So when man learned how to use cement, he did not replicate the wooden designs that were there in the past. He learned how to use concrete and the strength of concrete and then design for that thing, You can't take the old process and then replicate in the new ecosystem. And so by doing that, you get into this whole rebuild the whole same thing again, and then, which you won't get the power of the digital tools that has been brought into the place. And then there are a lot of these apprehensions that, our setup is too complex. It won't work for us. We have this mix of, we need to do this, we need to do that, whatever. So I will show you some examples through case studies that, it's not so. So if there is a will, there is a way, right? And then this classic thing, right? After all the discussion, it will be, okay, fine. There is budget constraints, or, we will take this up for the next step. Basically, we will do this later, right? So, I don't want to tell myself that, I don't want to touch this. It's a nice way of telling ourselves, that, we will for now park it for some time, right? Remember that adage, Chinese adage, right? What's the best time to plant a tree? It's 20 years back. After that, now. Always now, right? So if you haven't done the digitization, it is at this time that, start thinking about it. Because when there is, so if there is an advantage that you have planned, or if there is a process that needs to be replaced, that basically becomes the tangible benefits that you can actually see. But digitization provides a lot of intangible benefits. It can't be measured, but it brings in that that benefit, right? Like for example, efficiency, productivity, these are all straight stuff. Sir was talking about scalability. So the level of scalability, what an Excel file provides versus what a data set provides, and then in a tool like an Oracle or SAP or whatever. It's a very different ball game altogether. The decision making becomes very fast. The way we visualize data becomes extremely good. I implemented Power BI. I mean, it's a very simple analytics tool, and what data you have in Excel, you can just take that and then put that in Power BI. But the insights that you get, from Power BI, once you start looking at the data in that manner, is very, very different. So in my previous organization, and so what insights I could actually provide, people were able to see only 6 months later. So at that time, people were, how did you know? So I said, here, this is the tool, do it, free, available as part of our set, right? But the thought of getting in, doing it is what is really required, and that what I request the audience to start thinking, when you go back to your place of work, when you start looking at your investments, think about all the things that the digitization can come in, the benefits that as an organization we can get. And with that small preamble, I will try to show a few examples that we have made in digitization. Specifically, the focus today is going to be on the vision systems. And we have, as Tata Technologies, we have developed a vision system, and it actually has the engine of AI ML. I'll talk to that briefly. And these examples are basically using that tool. It has been there, but it is not selling that tool. There are similar such tools available in market, and therefore see the examples as a use case for vision systems, A, and B, think beyond, right? That is something that I request my customers always. If I show this example and if the thought comes, oh, I don't have this particular case, therefore it will not work. It's not the right way of looking at these digital assets. Think of it as a system has got brains and then we have given it eyes. So what can we do with these two additional features for a system? Then you will start opening up your thought process to see the possibilities of what the digitization can come. And in this particular example, this was for a radiator manufacturers, and so they had almost 230 plus different configurations, small volumes, and then the expectation was that these edges, they used to get damaged, and they wanted a system for quality check. And so basically we did this complete project for them, including how to hold the radiator, and then setup of the how to take the photos, and then the back-end system for reading that, training the model. We have few pre-trained models, and then we had to train that again. So all that, and basically we came up with, here is a small video which I want to play for you. Yeah, so what you see is basically there is a defect that it's being pointed, and then in the mobile the same data is being captured for the vision system, which goes to the vision system, which is this, wherein the defect has been highlighted. And so for this basically to happen, the model needs to be trained that to identify that this particular thing is basically an error. And so with that database that is available, it sees what has been given to it and then compares, and then identifies that oh, here there is a issue over there. So which, if you extrapolate in your manufacturing setup, it could be an operator who is assembling something. Forget about this. If there is a 20 parts that needs to be taken from 20 bins and assemble. Now if the sequence is changed, you can put a camera over there and then train the model to track what component is coming after what component. And then if there is a difference in the assembly process, it gets flagged. Or if the incorrect part is picked from the bin, that can get flagged. So it's basically the limitation on the digitization is the limitation of our thought process. So what we can imagine, the capabilities are there in these systems to go beyond that basically. So next, here is one more. So you might have a concern that, oh, okay, fine, that is a very static thing. You have kept something over there. There is a lot of time to put and measure and all. Mine is a process industry. Things are moving very fast. Digitization won't work. Here is an example which I picked. This is steel mill basically. So what you see here is, this is the steel roll that is running anywhere between 300 to 500 meters per minute. That's the speed at which it's going. And so the use case there was that, there were blemishes that were happening when the rolling happens. And so the manufacturer wanted to identify where those blemishes were, because after that it goes into a roll. So if they want to fix it, they need to know exactly where it is. So they wanted to identify where it was, take its coordinates, and then ensure that, later on if they have to fix it, when they unwind it, they know where exactly to go. So that was basically the use case. So here is a small video which, it's playing. Not playing. Okay. Yeah, please. Word for it, that's a video of steel roll which is actually going, and then what you would see here would be, this keeps going, and then there would be this red block that would come sometimes, and there would be, so which basically kind of picks up that there has been issues over there. So the speed is not a problem. Speed is not a problem. So if you have a process which is going fast, it still works. And you might have seen few sorting kind of applications. It could be something used in industry. I mean, even in recycling industries, these things have been, where the feed is actually fed back to a robo, which actually goes and picks the material so that the sorting happens, glass versus plastic versus paper versus whatever, right? So it's basically the application. Now here is a third one. This was basically done for airline industry. So before the flight pulls back, there is a pin that would be there for the landing gear, so that landing gear accidentally does not fold when it is parked. But then the same pin needs to be removed perfectly, because if not, when the flight takes off, it can't pull back in. So it's basically hazardous. So the Singapore Airlines basically wanted a solution where they wanted to check if this has been happening when their technician comes and removes that thing. So we did a video analytics on this, and I hope so it is identifying that there is a pin. So the operator comes in, and then he pulls it. it even tracks in his hand that the pin has been removed. So the importance of this case here is that the size of the component, basically. I mean, with the size of the environment that is there, the complexity, you will have to see that. So at the end of the day, it is the complexity of how much elements are there within the video, right? Within that, the system is actually able to identify what specifically you look for. You know, it's a small pin, and then it identifies whether it can actually be done or not. So if the concern is my components are too small, and then the analytics may not be able to work on it, the vision system may not be able to work on it, that's not the case. There are examples where it does work. Here is a little more simpler case study, wherein one of our customers during COVID time, he wanted to know that people were following the social distancing, and so they wanted to identify if there was if there were issues in terms of how close people were coming. And so we showed this, and then we also said, we took this to few of our material handling customers as well to show you could use the same algorithm, but then train it instead of people, you can train it for machines. And then you can see if there is a collision part. Did two forklifts come too close to comfort? Or something which was supposed, did an operator's head come too close to a overhang? Anything like this can actually be done. So we basically provided that use case for one of our customers. So let me just show that. I'll not play the video fully. I think it has the same issue here. Nevertheless, what basically happens is when they're too close, it turns red, and then there is a counter on top, the counter increases. So,
We trust you.
yes, thank you. This was a case again for, see the versatility of the solution, the digital solution, right? So here was a case where the customer is basically a power sector guy, and they wanted to know the rivets that go on these towers. What is the level of erosion, the corrosion that is happening? What is the health of the towers, right? And the process that they followed was that people would actually climb up and then test and check each of these rivets and the quality of the rivets, the quality of the tower corrosion that's happening, and make the decision. A, it's unsafe. B, time consuming. And then C, there is a lot of data points which might get missed, and so they were looking for a solution that was there. And so the solution that we provided was a drone based system. Everything is same, right? Back end, it's the same camera capturing the same image, going to the same vision system, but then the way it is getting captured is through a drone. So fly the drone, get the images, put it back into the system, and then we identified that there are like these 5-6 different types of corrosion, or the way the things can fail. So those systems could, those issues could actually be identified on the system. So there is no video for that. Visimatic is the tool that we have developed, and if you are interested, please feel free to contact me. I will put my team to explain to you a little more in detail on the architecture, and even maybe your use case, and then how it can happen. So there are a lot of module-based solutions that we have developed. So you will basically be able to combine multiple things and then create solutions. So if it's of interest, it could be taken. And then one quick thing I want to talk about, right, is this thought process that, are we choosing the right thing? Is that investment really going to be of use for me? This tool is so flexible, so lean, that actually it can get on a Raspberry Pi. And if you know Raspberry Pi, it is about a 4,000 rupees board, and a lot of hobbyists actually do it for programming and doing some small robotic stuff. This is basically a robot. This is a Raspberry Pi, and this is a small camera, and we basically did a small POC which had about 2-3 features. This was basically for an automobile manufacturer who wanted to do drowsiness, basically fatigue monitoring system. So we proved that this is possible. You can actually track the movement of eyes and then predict if the driver or the operator is actually feeling drowsy. And so I think I didn't include that video, but so something as simple as that. Is that a production solution? No, you still have to do a lot of work to take that to production. But to prove that will it work or not, we have something over there, right? So that's the thought process there. And here is one more framework that we have developed that we call it as Smart Industry Readiness Index. A lot of times question comes in as to where we are and where we need to go, because there is a lot of this thought about Industry 4.0, we need to bring this, we need to get digital tools. So a lot of these thoughts come in, but there is no map per se in the industry where, at least which we have not come across, where we are able to make a qualitative, comprehensive assessment of where we are, and then jot where we want to go, and then provide a map, a roadmap for how to go there. So that was an ask from the industry, for which we basically developed a roadmap, and we are trying to popularize this as well, so that it becomes a more accepted industry standard, the SIRI framework. Comprehensive, almost 20 different parameters, and then it is basically about a 2 to 3 weeks of activity at the plant. Detailed assessment happens, and then identify what is the current maturity level, and then how to get to the level based on, there could be a lot of constraints, it could be product constraints, capital, time, so be it. But taking all those, providing a roadmap for those who are interested to go is something that we are able to get over there. So in summary, digital basically is there to stay. There could be concerns in your mind, but then it is something that can be overcome. The technologies are out there which may feel expensive, but from the overall benefits that they deliver by implementation, it is very, very different. So, so start thinking in terms of having your digital journey, because to start, the right time is now. So, thank you very much. Any questions?
So I have a question.
Yes, sir.
So can you just go back to that slide, image tool specifically, the data analytics, image capturing, that tool. So generally, if we say the data analytics, so, Visimatic, something like that, does it comprises of the extraction of data from the different data sources, then make it in a kind of in a structured format?
Yeah.
Then we can prepare or build and deploy the machine learning algorithm or model. We train the model, and then we can capture it in a visualization analytics.
Yeah.
So all these 3 parameters can be well captured in this Visimatic.
Yeah, it goes beyond that. Actually, it has OCR capabilities. It has actually handwriting capabilities. It can actually take voice. So all these are basically built as modules, and we have put that on cloud as well. So it does not matter what your source of data is. So here the case is, we have taken the data coming from camera and from video camera, and then use the AML, the analytics capability, video analytics and video analytics capabilities basically to provide these use cases. But the data can come in any which way you want.
Okay. And visualization analytics also takes place in the same environment.
So we have few use cases where we have actually done the invoicing, the PO correctness, or extracting the PO and then putting that into the system. Like that, there are multiple such use cases possible.
Okay. Thank you.
Sure.
Good morning, sir.
Sir.
Thanks for giving us the presentation regarding the Visimatic. With the same thing, I am talking about a normal manufacturing process in terms of a SMD. Okay, in a SMD we are implementing the AOI right now. We are using a AOI, automatic optical inspection.
Okay.
Okay, it is also vision system.
Same, yeah.
Right?
Yep.
So we are giving one reference image to that, and whatever the actual image is coming, so we are just comparing with that and we are making a judgment,
Yep.
it is okay or not okay.
Yep.
So it is basis on some data which is already there.
Yep.
By using some AI ML, what would be the added advantage I can give with this system or with this technology, and I can get a more correctiveness, because after AI also we are finding some issues while we are going further in the SMD manufacturing. So what it can help us, that just
Yeah.
one. Yeah.
So, so by bringing the AIML engine, the ML part of it, so that is basically what is, I think, the key advantage, because the system keeps learning from the inputs that come in. So it is just like a small kid growing up, right? You know, so the more it gets trained, the more accurate it becomes. So the other advantage is that, you know, there are pre-trained models that are available, so which can actually give a shot, just like Matrix, right? You know, just download. So something very similar. So we have about 1,500 pre-trained models for different scenarios, which can actually give a head start. So these are some of the advantages that brings in by the AI part of it. But by nature itself, bringing AI technologies into it, you can actually extend it much further to Gen AI, and then you can have query on those things. It can start identifying patterns out of the issues. So it depends on how far you want to take it forward, because it's limitless.
Okay. Thank you.
And also, just a clarity, this is not Visiomatic as a tool.
Yeah.
I am kind of aware of this as a tool. We have worked it together, but similar tools are available outside as well. So it's capabilities might be different and then stuff. But my only point also is that when these thoughts come in, try also to work with the experts who understand the system, because a lot of times we see that the thought process that we can do this ourselves, right? So while it is true, you can take it to a certain level, but working as a domain expert with the tool expert or the solution expert, you will end up with a much better solution than developing the tool and for the domain yourself.
Check.
Yes, sir.
Hello. This has been a great presentation.
Thank you, sir.
If we could go back to that slide about the landing gear.
Which one?
Landing gear.
Ah.
I have a question on that. Yes. I do documentation and content for aviation and aerospace manufacturing. That's a part of my work. What I would like to ask, apart from the front part of the landing gear, sometimes what happens is, especially during the landing, if it's a hard landing, some of the components within the landing gear get damaged. So have you worked on any solutions which could incorporate image and video analytics to detect the same?
Okay, so 2 points here. One was, this was actually not a landing gear example. I used this example to show that a size of a pin in a complex environment such as what you see over there, the systems are capable to actually differentiate that stuff. That's point one. Point two, I come from industrial heavy machinery background, so I don't know too much about what is happening in aero, but I do know that they have been working on few predictive maintenance algorithms and stuff, but we can connect after session, during breaks or something, where I can connect you with the right people who can provide you some insights there.
This actually is something to do with predictive maintenance more than preventive in aviation. Yes. So thank you. Thank you for your answer.
I have one view. Shirish Kulkarni, can you go to the maturity framework diagram? Two views. One is how is it mapping to Industry 5.0, which is a next gen, has been existing for maybe 3+ years, not much adopted in Indian context or across the world, has 3 pillars. But how does this map to 5.0 was one viewpoint which is important. Second is manufacturing in specific for electric vehicle would have some flavors and variants. So is it catering to that also is the second part.
Okay, all right. So answering your first question, no, this does not incorporate Industry 5.0. And the reason also is because we mimic where our customers are going. So to a large extent, because at the end of the day, we do, of course, investments to develop few things and show. But predominantly, if we follow the customer, then there is money, right? So at the end of the day, we need to show revenues as well as business leaders. So this basically was a framework that we developed to actually position for some of our known logos to show that, bring a structure to their thought process and then, map that across. So since they are not talking of 5.0, we are not talking of 5.0. Second, this is a industry agnostic framework that we have developed. So I am sure this should be applicable for EV as well. But if you would be interested, I can bring the right people and we can have a separate discussion after.
Definitely, it will be interesting to have that flavor
absolutely
within that.
Love to have that.
Thank you.
Sure. If there are no more questions, thank you very much. It's been a very, very lovely audience and I really enjoyed this.
Thank you so much, Dr. Vidyasagar. It was truly an insightful session. And now I would like to invite Mr. Dhiraj Bhalerao to the stage to felicitate Mr. Dr. Vidyasagar. Thank you, sir. Our next speaker for today is Mr. Shirish Kulkarni, founder of Stora Consultech, with over 25 years of industry experience. He'll be talking on the topic of EV manufacturing. Let's give him a round of applause.
It's not connecting. It's not connecting. It's just flashing. नहीं हे कनेक्ट नहीं होते नहीं हे पण कनेक्ट नहीं होते प्रोजेक्ट नहीं होते it from a drive on this. Switch off the copy. Just not working. Can we check?
Now they got it.
Extend the container. Has its own surprises, so it took some time for the setup. I had a Windows laptop which is typically universal, gets quickly connected, but global is global. Here only I believe Apple is working well. Anyway, so that's something that we will start with. What I'm going to do is give a perspective about electric vehicle manufacturing aspects of what component goes in. Some perspective about what are the parallel lines we can draw with IC as a vehicles back to EV, which is a new next generation. So we'll draw those lines where commonality is existing, and some commonality which was leveraged, not leveraged, maybe 6-7 years back, and some degree of compromise or fast tracking that has happened for complete product development, R&D to manufacturing process in the industry, eventually resulting into some setbacks in the industry, and hence a certain legal perspective got tighter, and you would see those coming into picture. Slide changer, I guess. Hi. Slide? No, it's okay. It's fine. All right. So we will take those perspective. We'll lay down in the beginning the whole ecosystem, right? Electric vehicle, as such, when we look at it reducing components from IC engine-based vehicles from 2000, say, to 600, 700. Is it so simplified? Is a perspective. The whole manufacturing gets very simplified. Was the nuances that we started with, and there was a notion that we will, in Indian context, we'll import those assemblies, sub-assemblies, get them together. I will not call it integrated. I will not call it tested. And then, go to market where EV was something which was definitely flying on the horizon and everybody was eager. Market was supposed to be kind of ready with innovators to start buying those products and experimenting with those. It did happen on the two-wheelers, three-wheelers more, not much on the four-wheeler side. Four-wheeler side, it took good amount of time. If we go back to the genesis, it was Reva, which was a first four-wheeler that you would find in Indian context that got built, delivered, and it actually served the purpose, coming at 4.5 lakhs rupees in Indian context. When it was taken over by Mahindra and Mahindra, and we were waiting for the next gen to come, so in the form of E2O, it took them 7 to 8 years. And still, if you look at the sweet spot for a vehicle which is affordable at 3.5 lakhs rupees, 4 lakh rupees, I think there is still a struggle there. So whatever got delivered at 4.5 lakh rupees that time was a solution, partial solution. But eventually, if you see, then there was a lull on four-wheeler side. There was a lull. There is a question to be debated about whether electric vehicle is really in the green state or not. We will not go into that. There are some slides that I have about cradle to grave analysis about how it generates whatever carbon footprint or greenness in the process. We'll not go into the details. So these are the perspectives. We'll get in more details in the slider. Couple of slides about me and this. So thanks to you and Efficient Manufacturing for this honor, for being present in front of you to share my thoughts. Whatever I have collated, I have experienced out of interaction with various OEMs, various small and medium scales, and the challenge that they have about various individuals to start their businesses and stabilize them. I had this is my career graph. I had been part of Tata 3 times, was part of Tata Motors ERC, was part of Tata Technologies, definitely, when it actually got germinated that point in time. I was part of TCS, actually heading manufacturing excellence, and digital has been something that I have been very close. So it was about 15 years back, the manufacturing excellence as a topic for TCS was carved out and presented at that point in time. I am also helping out a global analyst firm, parallel to Gartner and Forrester. ESG is the name of the company, and being a senior analyst on that to write my perspective about digital as a space. So tables have got reversed. When I was in TCS, I was actually presenting for the new things that are coming on the horizon to the analysts, and now I am seeing those 40, 45 CXOs presenting their perspective of what their companies will be doing, the Accentures and McKinseys of that sort. So got a good kind of a perspective about manufacturing excellence, industry 4.0, smart manufacturing, IoT. I'm helping small and medium businesses for last around 7 to 10 years to help them to succeed more, to be more efficient, and most of them are manufacturers. So a manufacturer that I have helped is to grow itself from X to 3X in its top line in last 3 to 4 years before pandemic. Certain things that I would like to, so this is the example of being lead analyst for ISG. You can just check whether technology work, whether this scans, and you get to see my perspective. If you want to just scan this out in your camera, check it out, whether it works for you. This is a perspective presented around 1 year back, which has got all the nuances about what digital framework is providing and how it takes us in the world. This year, I'll be setting the perspective for the next year moving forward. All right, so enough about technology. This is another perspective, the question that I asked about 5.0. I believe some perspective were shared for industry 5.0 as well. The generation of how 4.0 culminates into 5.0 is something which is already presented, so we can take a leverage out of it. Now, focusing on electric vehicles and the mobility system that we have, we would like to see that this problem, if we'll take only electric vehicle, the problem that we see for adoption of the electric vehicle and also the whole products being stable, not being stable in the Indian context is definitely not a single pointed or simple problem to solve. As we thought that the components are getting reduced, number of components are getting reduced, but the degree of complexity of the components that we see moving forward is indeed huge. So it is not something that is isolated to be solved like just to be assembling and shipping it out. The established processes that we have in the ICE engine specific vehicles, and you will see that the OEMs which are successful right now are Tata Motors, Mahindra and Mahindra, who have been actually running this battle for last years together. And if you see the benefit that the product like Nexon gives, the quick highlight about how platformization is critical. And if you have heard this word into the software space more than the vehicle space, it is where both the worlds are getting culminated. The next generation electric vehicle has got a lot of integrated systems, lot of embedded system, a good amount of software that gets into all the subcomponents that you will see in the form of battery management system, controller management system. All this has to work in integrated way, and then that is something that has to actually work in the production. It has to be tested, and eventually that the product has to run well. If you see Nexon as an example, if we take in Indian context, I feel proud that was always a part of Tata Motors and have seen those product struggling and being successful. I see that this is a great success that we need to celebrate, though it is a monopoly that Tata Motors has built right now. But they are ahead of the curve. If you ask in manufacturing parlance, what is that they made a difference in? One is that the platform which was successful in production, very successful as a Nexon vehicle in ICE, was reused, was standardized. So exit point for electric vehicle or decision making for electric vehicle is where you will see that the electric kit is getting connected as the vehicle deviates from the ICE line in the conveyor belt towards getting that created. The whole electric vehicle kit was outsourced. It was actually outsourced to the Tata companies only. It was a Tata company only. Electra Drive was the name of the company, and Ratan Tata invested onto that, and eventually that grew further. You'll see that the whole quality of the electric vehicle kit is key to success, where it gets directly integrated in the conveyor belt. So those perspectives are critical, and I would strongly say that those are the success stories that we need to actually look at when we talk about manufacturing as such. If we look at the phase-wise, the way that it actually goes, now this is example of how aspect of battery manufacturing to be actually, if you want to actually look at a simple problem that needs to be solved, it's not a simple problem. Talking about battery to be standardized across various vehicles and battery swapping to be actually incorporated in electric vehicle parlance. You have something that is your own battery, you have only, and you are actually proposing for something that will actually get standardized across various OEMs. So this is a bigger problem to solve. If you see Piaggio for three-wheelers have already got battery swapping mechanism. They worked with Sun Mobility, and that was successful in a couple of states, but it is not further successful. What I'm trying to bring out is a huge problem that we have across components as standardized. I will not get into the details of R&D going in a battery system, but those components like battery cannot be standardized, though the connector could be standardized, though the chargers could be standardized. And this actually results into, if you want to actually incorporate it at the end of the cycle where you want to actually get it swappable, then you have to actually track back the whole manufacturing process to get it changed, incorporated in the design phase itself, where you have those aspects that you need to take into account. Taking further, what are those aspects that we need to consider if what all we talk about certain degrees of components that are there. So batteries, it has been always talked about batteries where the challenge lies. Motors is something which has got standardized. Batteries is indeed very, very unique for any vehicle that you are trying to develop. And talk about the raw materials not being available, not to that level, fires happening for battery, eventually results into impact that you need to actually alter the manufacturing process. Around 1.5 years back, due to fire instances, the standards for manufacturing got actually altered for batteries, delaying the whole program, say for Mahindra & Mahindra, I know for Tata Motors, by around 6 months. So any incorporation of a new standard for safety, for some component like battery, derailed the whole program launches by around 6 months minimum. Material shortage has been talked about, eventually resulting into, say for battery, you need to have sodium-based batteries. Now, are they actually stable? Yes, they are stable for fire. Are they actually manufacturable, and do they have that kind of power density that we need for vehicles, for the weight ratio that we have? Still under discussion and question. So those perspective, whenever we change any chemical composition or composition of a battery like a component, the whole manufacturing process is going to be changed as well. The validation process will get changed further. Cost is an element which actually gets debated about. Government gives some kind of aid, but manufacturing wise, though you get help by money, your technology, how you manufacture it across the value chain, the way that you get the inspections into place, the way that software integration happens, the way that you test those systems, getting those use cases upfront. We heard about visual inspection. So all elements of Industry 4.0, all technologies that you have about Industry 4.0, mapping that back to your manufacturing system. So, in a nutshell, if you step back, we already have ICE engines based manufacturing system established, very well running. You have Industry 4.0 and IoT like elements where you enable it to be further more efficient, better, giving more results, reducing the cost, improving the efficiencies. All those KPIs are in place. Now you are adding simplicity / complexity of making it simple by number of parts that you have. Rather than 2000, replace it with 700 parts, but extremely maybe 100 times complex systems, subsystems, which actually, if you even think about a gearbox for that matter, a simple drivetrain that you have for the car, it gets replaced by what you have as a battery management system, motor controller. The whole behavior that you want as an experience from that vehicle, right from the acceleration, the torque conversion, is you are expecting it out of those systems, and those systems have to be programmed, tested, and eventually validated for that kind of a performance that you need to have. So it's definitely a complex beast to have, and I think world is clearly showing about what competencies it requires. It definitely requires high-end competencies which are critical for being successful digitally. I think we quickly talked about platform. So platform definitely is a key to success, and we highlighted Nexon as one of the examples there. We have battery management system. Those aspects of manufacturing that could be outsourced to the OEMs which manufacture batteries, similar for motor controller. Then you have other sets of complexities involving inverters, converters, integrated power converters, onboard charging. Now, these are elements actually going inside your vehicle and makes your life more and more complex as we go further. We talked about, EV kit as such, which actually consists of things that you fit only as a part of making your vehicle EV. Then that's where either you outsource those elements as far as the quality is concerned to the vendor that you got to make sure that whatever components that you got or subcomponents you got have the kind of quality and performance criteria already satisfied so that you are onboarding them directly in your line. So typically if you see, still we are struggling with the overall turnaround time. I'm highlighting more of the issues that we have for manufacturing. 24 to 30 months is the cycle time that we are talking about. It was actually tried to be thrashed down to couple of months by assembling imported, I will say, some Chinese component and sub-assemblies there, but it is still something that is a challenge. Whenever we are talking about outsourcing certain things like powertrain as critical component as powertrain, there is also a tendency that we need to have that in-house capability to design them. I am working on a project actually to check what is the efficiency of the powertrain, what are the losses involved into that. So if electric vehicle has got 82% of efficiency, 18% are the losses. So what are the individual constituents contributing to each losses? What is the sensitivity of each parameter? Now this could be vibration, it could be friction, it could be inertial, it could be misalignments that you have. So out of 82%, now ICE vehicle had been around 33% efficient. We are moving to a very, very efficient machine here. But still we are lost, in loss for those 18%. Can we reclaim those? Is the research that I am doing as my part of thesis, working closely with a couple of OEMs, and I will be interested to talk to you also how that actually works. And if at all we are out of 18% able to reduce 1% to make it 17% as the losses, whether our range, say 100 kilometers increases to 106, gaining us 6% of benefit directly to the OEM and hence the end users. So that's the kind of impact that it will have. It will also have an impact on manufacturing process, design process, because this work is going on with R&D department where the complete efficiency of the drivetrain end to end, right from where it gets generated from the battery, translated into electromagnetic efficiencies that you have within the motor, translate itself into a rotational motion into the motor, and eventually through the mechanism to the wheels. Everywhere you will have to actually identify those elements, and that would be the outcome. Cost is element for EV. I think we will leave that debate. You will see that even lithium, if you plot all the graphs for the trains that we have, every year the price is getting slashed by around 22%. So leaving 20% itself, in 5 years you will see that the price will be 1/5. So rather than just questioning ecosystem that we only have problems with electric vehicle, not to be adopted, I think we should focus on the energy density that we get through the lithium ion battery, and if we want to get the sodium as a solution, whether it makes sense for us that way. Right? 68% of OEMs are definitely looking at having that physical integration and in-house powertrain. And whomever I am actually interacting with in India, they have shown a great interest to build that powertrain which is more stable, integrated, tested in-house with the use cases and test cases built end-to-end to help us. Right? This is a typical week of validation and verification. Highlighting that we cannot do away with this. This is a very core element of any ICE vehicle that you will see, and it goes rigorous validation verification. It's a control point for your manufacturing. And if earlier we have seen some deviations into this, I think ARAI has come very strongly onto this, where this is actually very strongly recommended. And it's a process of learning for new manufacturers, yes. They were saying that it was a quick kind of win for them, but they have learned it hard way where this kind of validation, focus on verification validation is extremely critical, and ARAI like entities which are helping. There are huge sets of advanced machinery test rigs which are available and which could be utilized for bettering your performance and ensuring that right upfront when you are manufacturing plus designing, that you get those controls in place. So quality becomes important and testing becomes important as you proceed yourself in the manufacturing value chain. I would just like to highlight another perspective about ICE engines, vehicles versus EVs. Typically, if you see vibrations, right, and we talk about engines having RPM of 3,000, 4,000, 5,000. Sports cars will have 10,000, maybe 15,000 RPM. Firstly, EV have got efficiencies which are 82%. So it's a very efficiently running machine. One, two, that whenever we talk about the RPM of a motor running on board, it's more than 15 to 20,000 RPM, which actually we reduce it, we pass it through gearbox and make it something which will actually be like ICE engine to drive our wheels. Because we want to keep most of the things as is, as were, and then adopt only to those things which will change. The whole aspect of harshness, ride comfort are completely different. If you look at the frequency domain, those have got moved 3 times more frequencies, higher frequencies. So if we were going to have 12 hertz, 13 hertz as a natural frequency domain for ride comfort for engine-based vehicle, we don't have that source at all, right? We don't have those vibrations. We don't hear that voice or noise, but we hear different noise, which is whining noise in the motor, which happens at the higher load and higher RPM. Those are the elements actually come into picture when you talk about electric vehicle. So the whole paradigm as R&D has got changed, and hence, though it is, we can simply call it a simple machine to manufacture, the complexities are definitely multifold. So it is not only the integration of electronic systems, software systems together, but also looking at those parts which are homologation, supposed to be called as homologation, where the whole vehicle gets passed through all these tests to be called as manufacturer okay for consumption by the end users is critical, right? These are some perspective further for validation. Platform is a key to resolve. I believe that this has to be actually standardized across OEMs, and I see even Tata Acti as a platform which is could be taken an example where so many of the products, Punch, new vehicles are getting created, and if you can see that anything which is standardized, accepted and proven a vehicle or the model which is running in the reality, the whole cycle will get reduced by 1/3 or 1/4 if you have a platform, because 70% of the things will remain the same. You don't need to reinvent the wheel. Remaining 30% is where you validate. Once the platform gets validated for the deviations that you have specific to the model, only those changes have to be validated, and that becomes an incremental process. So if you see conventionally in software development, they say about agile way of working, where you cut the cycles to limit the kind of risk. I believe that this is coming into, this is called as agile manufacturing. This is coming into manufacturing in a big way and has to be adopted. Some highlight about where nuances of latest of the digital technology will come into picture in the form of drones, analytics, blockchain. Blockchain is an interesting stuff. I have not seen much of thing happening apart from banking sector, but in manufacturing, wherever you see that systems are getting extended beyond the firewall, and vendor management system, dealer management system are the examples in the auto space, where you have automatic authentication of any payments, vendors being pre-qualified to have a certain degree of level of competencies so that the parts goes without sampling, without quality inspection directly onto the conveyor belt, are the examples of blockchain, though are not claimed to be blockchain, where those elements can come in, where pre-approval of partners and direct connect between those things can happen and will help. So these are some aspects of where digital is going to impact. In fact, it has already been there. And that's what's the question that I asked about certain things which are agnostic to any kind of manufacturing should be existing for electric vehicle. Also, with the flavor that the complexity that we have has to be addressed in this perspective. One example of battery swapping ecosystem where not only that you need to have the alignment of the battery manufacturers about the standardization in their manufacturing process, but how that actually impacts you as an OEM to better you in the way that you are handling it upfront in the form of the way that you design and manufacture your own vehicle. Another example where 3D printing is a dimension that is taking popularity. This is a Chinese example, and we would see our own examples in auto. I'm working with a dental parallel, and they are printing heart also for that matter. But in reality, I'm working with a 3D printing company which is working in dental space. To create, all the parts that you require for dental purposes. Cars, if you see now, this is the turnaround time for each of these component, and we need not standardize this, but we have to have it for our own vehicle, how the 3D printing will work and can be adopted. So, in a nutshell, definitely the whole experience that we have for ICE vehicles have to be leveraged. There was a dream that we had that you can, we don't need to be understanding the auto principles, fundamentals, and kind of fast track ourselves. I think lessons learned, we should actually bring those back and be strong. Start sourcing, create those vendor environment in which you have pre-qualified perspective, and outsourcing also, and insourcing. So wherever you think that this is a competency that you need to have, make sure that you have it. And for that, whatever design tools that we need to have, testing tools that we need to have, so that manufacturing is an outcome, right? I mean, manufacturing is the same. Manufacturing is the same for years together, but are we making our product more intelligent and capable by that is a key to success. I think tighter integration and in-house capabilities for manufacturing is definitely a key. So I think a great horizon for us, I believe with Tata Motors and Mahindra, seeing the headway creating that monopoly, we feel proud. But again, we have to be wary of the outside competitors also coming in, and we should always create a curve where we are ahead of them 6 months to 1 year. With that notion, I will stop here. Any questions? I'll be open. Yeah.
Do you think we need any policy interventions from the government to address the challenges that you've spoken about, especially regarding sourcing of rare earth metals, or in terms of localizing or enhancing capabilities or giving incentives? So do you think we need some of those policy interventions?
Okay, it's a big question. I think it touches the chart that I had about the whole challenges that you see in the ecosystem for electric vehicle itself, whether existing, not existing, whether we should actually short circuit it. So I'll try to restrict it with the manufacturing perspective, right? Answer is yes. We need to have those governances. The question is, why? Yeah. And if you see, again, this is a little bit of a political answer, because okay, let me give my heart to you. That I'm not seeing the kind of drive that we need to have for adoption, yeah, and the kind of encouragement. This is my personal view, nothing political about it. I am not seeing it for 3 years. I've been closely watching this market. I've been closely watching the adoption. I've been closely watching the retrofitting aspects also, where you have 100 vehicles which have to be converted. We are talking about 80+% to be converted into electric vehicles, and we can convert 80 of them by replacing those components with electric vehicle kits. Is it cost effective? Yes. If at all we take two-wheeler example, it is costing 40,000 rupees. If you save 3 rupees per day, run it for 60 odd kilometers in a day, 1 year you will get 38,000 back. Is there any guidance? Is there any encouragement for that? I would say no. Each vehicle, and he's witness to that, but each product that you have, each variant of the product, to have that kit to be approved by ARAI is around 50 to 60. Not ARAI, but any kind of qualifying agency is around 50 to 60 lakhs of rupees. Okay. So it's absolutely deterrent. The kind of support that we had for production incentivization has kind of depleted at state, central level also. You will see the benefits that we have in the form of FAME policy. March, those who got ended, exactly. They have not extended.
Exactly.
So I don't understand. I don't understand. I have the same question. Why and where government is either, they're talking about hydrogen, they're talking about alternates like sodium. Yeah. I mean, is it there? Is it ready? We talked about some kind of source found, right, for lithium.
Yes.
Is it only the source found, or is it something that is processed and then you get the rare earth available with us? How many years that it takes? 4 or 5 years? Has anybody answered that question? So I think I resonate with you for the question. There have to be stricter regulations. But then, stepping back and talking about the corporate perspective about if Nexon is successful, right? And I've been taking that name a couple of times. It has passed through all the difficult filters that all the ecosystem has put in place. Yeah. The charger system, they have got that successfully done. How they have done it is that Tata sets of companies have come together to take care of that whole charging system. The whole ecosystem. There is a case study on that. So I would say one way that I don't want to point fingers that government is doing or not doing. Let them be whatever doing. So battery swapping has been around, which will solve the problem of range anxiety, everything. The whole, if at all you take the electric vehicle as such, the 40% cost is battery. Is battery, correct. Right? Yeah. So if I am buying it rather than 100 rupees, and we talk about cost of the vehicle and adoption and user, and if I get the same vehicle at 60 rupees, 40 rupees I don't have to worry about. I don't have to worry about the complete battery cycle at all. Charging, discharging, 4C, 5C, heat, fire, nothing. I have to, even talking about how we recycle battery is not my ballgame. Yeah. It's such a clean solution, but is it been adopted in the last 4 years? No. So that's my, with so many questions that I'm answering your question. It's a good question. I am striving to get some answers.
Thank you.
And if you ask me if I have to be part of that, whoever is making policy as a panel, I am also trying to figure that out is who's making those calls. So if that answers it well, I think.
Right. Thank you so much, sir.
Thank you.
Thanks, Shirish.
Yeah.
Being you as a subject matter expert, I have few queries to you. One thing is government has introduced FAME and PLI scheme. Right. PLI scheme has not become very popular. Even the big players, manufacturers, is opted out of it. And small players are not the part of that game. What is your take on this? Why it is so? Government has formed some policy without consulting the stakeholders, industry, or what? What is the reason to it?
Okay. Quick answer to that is there is this disconnect between the policies.
Agree.
Absolute disconnect. I mean, right from the word go to what we see, not only for OEMs, so battery standardization, you see that example, production related linked, whether that money has reached the individuals, OEMs is a question to be answered. There were huge amount of numbers of vehicles which are manufactured with the anticipation that the FAME policy will get extended. If you see before March, there was a slash down for prices, and they talked about that government is encouraging reduction of prices. It was not like that. It was the OEMs getting forced to get rid of the inventory. Otherwise, they would have made double losses. One is that they would have not got that FAME benefit, and they've reduced it to so much amount that they were actually selling in losses. So if you see, I can give you one perspective of one of the OEMs that I heard, Bajaj I have heard, that, and the second point I will answer you how we can get it there. he is saying that I will keep on producing 90% of the ICE vehicles. I'll pay, I understand the benefits of electric vehicle ecosystem. I'll produce 10% of them, which are EV. And nobody can mandate me, more or less. That's a clear stand taken by a OEM. Okay, now how does it work actually? Is there any kind of policy which governs these OEMs to have whatever carbon credits they are generating, either they get charged for each 0.1 carbon a couple of crores of rupees every year? So whenever they reduce that footprint by being green, either in-house and generating products which are green enabled, so that 100 crores get reduced by 80 crores to 80 crores, so they get benefit of 20 crores there. Is there any policy like that? There is none. It's existing in Europe and US. So answer to your question is, we have to hit the nail in the root where it matters. And that's the perspective that I as a OEM, okay, one more perspective, so taking that example of 90%, 10%, if I'm established as a business, right, I'm manufacturing and there are my end users who are buying my vehicles, and I call it as a cash cow, right? After 5, 7, 10 years, my manufacturing line is set up, I'm generating those benefits and making margins. Who and why should I change it to even bring that element of electric vehicle? You tell me what is my incentive. Production related, we can calculate the numbers, but those are not sufficient for me to drive me towards making me to lean towards, unless I'm some patriot thinking that, okay, green somewhere here on my head or company policy would help me. I need to have something like 100 crore if I'm spending, I get benefit of 80 crores if I reduce the carbon footprint. So we need to set that mechanism of measurement and penalizing for that carbon that is getting generated across the value chain by those OEMs, and hence if at all they do in a reverse way where they create efficient manufacturing process so that the carbon footprint gets reduced, they get the credit for that. So that's, I would say that my take on how we can.
What I think in a PLI scheme also, the norms are so stringent that people are keeping out of that, even the big manufacturers. I'm not talking about the smallers. If you talk about the two-wheelers, there are small manufacturers, many manufacturers, and they've been penalized for those and not to follow those guidelines. So I think that's one restrictions which is keeping the people or the industry away from this.
So I think you got it right, and actually it got created as a wrong example of governance where, see, there was a backdoor entry given for two-wheelers where two-wheelers are not required to be registered, the license is not required. If at all you build a vehicle which is 250 watt less than 250 watt capacity motor and which runs less than 25 kilometers, with the notion that I think 90% of the elements that you use there have to be indigenous or to be Indian. I think this clause were kind of dishonored, and you would have seen around 10 years back a lot of vehicles getting flooded. Just import things and you bring it together and sell it. That actually jumped the rules, and that's where the tightening happened around 2.5 years back. Actually, I lined up so many of retrofitting vehicles, and they've stopped it. So it is, I find somewhere the control has to be there. Respect has to be there for the system. But whether it is helping the electric vehicle adoption, answer is no. So who is to blame / struggle there? For those players who are early in the market, see, why are the foreign companies not there in the game right now? The clear answer is that if you calculate the cost of manufacturing, and plus 30% or 300% duties that you will charge for their sales, they said, no, this is not going to work. I'm going out. Still, they are not entering. If you see Toyota on the border sitting there, they've got the good hybrid there. It's actually waiting. It's absolutely parallel to Nexon, 22 lakhs. They're on the border. It does not require charging. So is electric vehicle a solution for us, or is hybrid? Hybrid does not have range. Hybrid, we are talking about a smaller battery. It maybe, it takes 3 to 5 years to So we don't have the issue about replacement. So why we are not doing that? Is anybody promoting hybrid as a topic against electric vehicles? No, we are blinded. We are just following EVs. Things. So I think it's a complex.
Great. Thank you. Thank you to share your insights of this.
Yes, she has one.
So that was something which I was also about to come up with. But as far to just add up to your discussions, I think the non-syncing between the central government and the state government has been playing a major role in ensuring or not ensuring that the incentives reach the end consumer, be it the manufacturer or the end consumer. For example, at the same time when FAME launched in Maharashtra, a lot of manufacturers have suffered, whereas in Gujarat, the subsidy amount has been transferred to the end consumer directly. So there are many beneficiaries there. So I think the sync and probably the openness of state governments to adopt and discuss with the central governments to implement, to define and implement policies comes in the way, is what is my opinion on this. I might be right, I might be wrong, I don't know.
Yeah, I think anybody who is working on those policy making, we should, they should be the one.
Is it between the governments also first, along with the industry? Industry comes second.
Yeah.
There is a sync problem with the state government and the central government while formulating the policy on this. Yeah, this is what I'm saying, and industry participation is must there. Yeah.
I couldn't agree more with sir. So my question to you is, when you spoke about measurement of the carbon footprints. So now we are talking about EVs, ICE versus EVs. Now, have we defined any parameters to measure in tangible forms what is the carbon footprint that we are going to leave in manufacturing of the EVs? Number one, have we defined these parameters? Second, should we be doing that before we start the manufacturing? I mean, in my opinion, that would make some sense, but I would like to know your views also on this.
Okay. Is there any standard? Answer is no, there is no standard. Is there any kind of definition that you will see of how much footprint that ICE manufacturing creates versus electric vehicle creates conventionally? There are good amount of research papers on it. And that ends the debate between whether we want to adopt EV against ICE, whether, it is around 2.5 years that you need to actually run the ICE vehicle, run the electric vehicle, where you have the tipping point of your generation of carbon footprint becomes lesser. But 2.5 years you have to be in the game for the vehicle. So it is an analysis where both for say ICE engine, you will have the engine components getting made, plus also the fuel coming and excavated and processed to become a petrol to be consumed at the petrol tank, and hence consumed throughout the life cycle, and hence the whole vehicle getting out of life. That's one scenario. The second scenario is talking about electric, so making of the electric vehicle, battery management system, all these harnesses, electronic systems together, generating some X amount of carbon footprint to make it. Plus, you have electricity getting manufactured, right? What is that you're using for electricity? Something that you're using. Now,
absolutely.
Right? Solar could be 23% efficient. Are you sourcing it? Is that sufficient? Wind energy, wow, great. How much energy, efficiency it has? Maybe 13%. If we take, the nuclear power, it could be around 34%. And it is all carbon, right? So adding it together to eventually get it there, and then the whole element of recycling and end of life for the vehicle. Bring those two numbers together is some research that we need to, actually there are elements where this is actually available in the form of projections. So if we calculate this for a particular vehicle, around 2.5 years of running of electric vehicle tips it over. So it is not a green kind of a case for electric vehicle. As far as carbon footprint is concerned, we cannot take it blind, no.
Absolutely. And then to add to it, I mean, I agree to what you said. To add to this, the kind of components that the EV manufacturers have been selecting and using in the manufacturing of EVs is so down standard. I mean, if we talk about the two-wheelers or three-wheelers, is so down standard that the frequency of those parts getting obsolete and to be discarded is very high. I mean, if there is a three-wheeler where a local manufacturer has manufactured it, say somewhere in Gurgaon or maybe Maharashtra also, the kind of the parts, the body parts that they have been using and the other different parts to minimize their cost of production is leading towards a high frequency in discarding of those parts, and again that goes in the environment.
So you're right. If we see the OEMs and the controlling agencies which actually come into picture for establishing the manufacturing process, and that's where those elements have to be coming also in the frameworks that we saw for 4.0. In fact, I'll answer it in this way. 5.0 as a framework has got three elements. One is that, you know, we talk about too much of automation, everything getting automated. So there is a concept, extremity of that is where you will start seeing dark factories, like 24/7, 365 days, everything will work, right? So do we want to eliminate human factor is a question that we had when we started automation. Now the question is coming whether and where we want to use the manpower. So 5.0 shows reintroduction of manpower in the form of control, abilities, the tacit knowledge that an individual has. You know, you still have those individuals who actually touch the engine and say that there is some problem with that engine, so you don't require testing for that. So that element is coming back in the form of control. So that is one pillar. Second pillar is sustainability. So what we are talking about is the carbon footprint or greenness of your manufacturing process, your product. Because what we are trying to do in either 4.0 or further is to bring that efficiency together with the notion of carbon footprint from the cradle, you know, from the cradle to grave.
Absolutely, absolutely. That's
so that element of introduction. So that's where I am going out and out to get 5.0 adopted, awareness created across to get adopted by industry. So 5.0 will get that sustainability element into place. Talking about the third dimension where you saw, certain kind of not so high-end components or imported ones which are kind of a black box. Now, you go for any two-wheeler or three-wheeler, you will see that the whole controller is a small box, right? And some plastic, some kind of wiring, some kind of soldering, and that's it. And you have to just throw it away and get a new one. I think that's the way that it works. But that's not the way that, and we are talking about, bringing those things in-house. When we saw that vehicle, even my son is in graduation right now, but he said, no, I want to dissect it. I want to create my own controller. So I would like to encourage that spirit where we have the control on what we create. We see, Tata Technologies, Tata Motors, KPIT dedicating their resources for more than 5 to 6 years, focusing on that kind of research. And those are individually, examples where we see being proud of those things being made by us. I believe that the plastic element or carbon element, I don't see those norms to be stringent. And I take your point that, we have to make it more.
Thank you so much. Thank you. Yes, sir.
Thank you.
Sorry, we are taking a little long time because this is a very interesting topic, but my last adding as per you, the carbon credits which talked about. As a general understanding, we think that EV vehicles are environment friendly and all this. But if you go in a deeper, it's not. It's not as environment friendly. One thing is when you charge the vehicle, you charge through the grid. If you go to the source of the grid, that is electric generation so we should have alternative energy to be adopted for charging purpose. The second point here is, after a few years, when we discard the battery, what will be the process to discard it or reuse it? As per my understanding, only 30% of the lithium can be reused. So as a journal, it looks like that we are contributing, we are environment friendly, all this, but in a deeper, we need more research and more technologies to support this as an environment friendly. So I stop here. Thank you.
I think only response to that, 2 points. To my understanding, China is way ahead of us in as far as lithium/battery complete cycle, manufacturing cycle is concerned. I have heard and I've read that 80% of lithium can be reclaimed out of the battery. Having said that, they have set up their resources in such a way, or they've set up their cash flow or flow of lithium in such a way that they are now investing only 20% of new lithium for their ecosystem. So their whole requirement has reduced to 1/5. So that's one example how we can look forward for being intelligent, more intelligent, and creating our own Indian ways of looking at those things. So I believe the other challenges that we saw are definitely going to be around with us. Now talking about EV, the way one perspective of end user is that if I convert my say Activa as a two-wheeler today into an electric vehicle by retrofitting at 40,000 rupees, the kits are available. I stop the smoke getting produced out of my silencer today. So that's one thing that we can keep debating about this life cycle of things, and leave it to say government to decide. I will keep on asking that question: is EV a solution or not? If I am supposed to take a decision to buy a vehicle, I would say that okay, I am stopping this smoke coming out of my silencer. I will buy it. Whenever there is a government-related policy that will decide that okay, you should buy a hybrid because it is better, that you create less of carbon footprint, and hence you get incentivized for that, I will go for that decision. So I'm giving an end-user perspective there, leaving us away and being part of technology and always trying to lead the curve. We have to take those risks where it matters, and if at all. I see that KPIT has diverted itself from hybrid focus around 5 years back to electric vehicle. Right now, there is a brain behind that. There is some decision. If we see Tata Motors producing and being so gung-ho about it and having such a kind of a stable of products coming out, I will feel proud about it and leave those problems. In any case, I'll end it with a kind of a perspective which is not so positive, but I'll end it. See, we talk about green, and industrialization and everything, creating this global warming and all that. A lot of debate, the focus ki ye karna hai, wo karna hai. But see, even for us to just be alive, if we maintain the same kind of population, we are every minute we are creating carbon. Every minute and second we are creating. So we cannot do away from that. So let's see how slow or how effectively we utilize the resources that we have and we pollute less is the approach I would say. And that would be that I will end it where I as a citizen, I would restrict to that where I take those calls. Otherwise, I have actually seen us only debating about these topics about electric vehicle and not taking my own decision of buying or not buying vehicles. So I will end there. Thanks. Yeah.
Hello. I have a small question. You mentioned expertise as one of the challenges. So apart from that, do you also look at R&D and testing as a couple of other challenges? And in testing, I would include physical testing and simulated testing also.
So it's a statement, so I agree. So definitely testing, simulated testing. I'll give you some perspective about that.
And talking about India, do you look at the R&D setups or facilities?
Indica?
No.
India.
R&D, research and development, and testing as challenges for the EV industry?
I would say there are two views. It's complex, but if you see that we have facilities which are the state-of-the-art facilities, each one costing couple of crores of rupees for testing of motors, battery, charging, discharging cycles, the whole kit together. Being closely watching that, and if you see, ARAI has got such, world-class kind of setups, though they cost huge per day, per test. We are there. There's no question about challenge as far as technology is concerned. How we are applying it for our product is left to the OEMs. And are we kind of passing some shortcuts? Is something that would be a part of challenge. But I think you take any OEMs that we have, huge sets of test facilities, R&D, knowing about this aspect, and I'm closely working for further improvement, right? I'm talking about that 18% still to be reduced, and it is getting encouraged. So I believe we are not stopping at 82% efficiencies, but growing it maybe to 90% if that gives us more efficiencies there.
Okay. And about R&D, do you think that we are really self-sufficient? Talking about India.
100%.
You
talk about Indian OEMs?
Indian OEMs, yes.
Yes.
Or are we still looking at technology coming in from foreign countries?
No. You talk about hybrid. If you talk
EVs.
about specifically hybrid,
Okay.
Toyota takes the lead. And if you see that Maruti has already collaborated with them and bringing out a vehicle which is white label, where technology is there. So if you say Maruti, the technology has come to us through Toyota.
Okay.
If I say the other OEMs like Tata Motors, they are in-house. Electra EV is definitely in-house, Indian kind of setup. They have been building this kit for years together now.
But Electra is a Chinese company, I believe.
Electra EV is not a Chinese company.
Okay.
It's something that Ratan Tata invested himself, and it is grown. It's in Chennai.
Okay.
And it's integrated very well.
Okay.
And if you see that there is a fleet of product Tata Motors is bringing out, I think that shows. See, we as Indian customers are extremely tough customers. कि थोड़ा इधर कुछ हो जाए तो we will not buy it. If you see so many lakhs of vehicles running, I really feel proud. I actually was part of Tata Motors when Indica was getting designed, and I saw that we had to go for Italian design, and we were R&D engineers that time. We felt so bad that our own designs are not getting approved or we are not there. But now the things have changed, right? But you see, if at all Nano was there, which was right time, right size vehicle, it did not get converted into electric vehicle, unfortunately. E2O is also not.
Correct.
It is not having that crash worthiness, and that is the reason that it is not there. But we have struggled, but I think we are there. I don't think we have to depend. Apart from somebody who is, see, hybrid vehicle, Toyota Prius, 25 years they have launched it. It's there in the US. I sat personally into a General Motor vehicle when I was seeing how it switches between electric vehicle to ICE vehicle. The simulation was on the board. I was testing that vehicle. So 25 years back it has been there. So there is nothing like we don't have it here. It might sound a little bit patriotic, but I feel that based on my understanding, we are not requiring technologies there. And the closer that I'm working on the simulation side, simulation-wise, you have products like Adams, you have products like MATLAB, where everything is actually available as templates where you can actually customize it to your requirement and use that for any kind of automation that you require. I'm making it very, very simple as R&D process, but those things are available. It's a matter of application of our knowledge, abilities and skills there.
ANSYS also has a few applications.
ANSYS also has got, so more focus on finite element, flexible analysis, crash analysis in the form Nastran. So all these tools are there, and if you see, I was part of Tata Motors where I was running those full vehicle simulations by my own hand that point in time, just change, all the paradigm that you require, the way that we change the kit. I will change all those elements that are required to be fitted in those simulation boxes together with different transfer functions, right?
Right.
So I think we are there. There's no issue. You have something in mind? I would definitely like to see where we are lacking. If you have something in mind.
We'll connect and talk in detail. Yes.
Okay.
But thanks for the answer.
Thanks. Thank you.
Thank you so much, Mr. Kulkarni. It was truly an interesting and an enlightening session. And now I would like to invite Mr. Arun Bhardwaj to come on the stage and felicitate Mr. Kulkarni. Thank you so much. Ladies and gentlemen, let the applause keep coming in, as I would like to invite our next speaker, Mr. Abhijit Kumbhar, who is a Deputy General Manager at ARAI. He's associated with ARAI since 15 plus years. He carries intensive experience in optimizing forging and forming processes and successfully catered critical manufacturing processes. Today, he'll be talking on the topic of lightweight forging, a way forward. Let's invite him on the stage with a round of applause. Same laptop, yes.
Good afternoon, everyone. Myself, Mr. Abhijit Kumbhar. I'm looking after design and simulation activities for manufacturing processes in ARAI. First of all, I would like to thank IMS committee for giving me a chance to speak in this forum. I'm going to talk on the topic of lightweighting forging. About ARAI, ARAI is an association of Automotive Research Association of India. It is established in 1966, and we are having multiple departments who are serving to the industry in the form of testing, validation, design and development, and consulting. I'm working in engineering, design and simulation department, where a virtual testing will be done and solutions will be provided to industry. We are also having 3 units in Pune, in Kothurud, and 2 units in Chakan, and touch upon points in Chennai, Bangalore, and Hyderabad. We are accredited with the 9,000, 14,000, 45,000, and NABL. But I would like to highlight here that we are also accredited for 27,001, which comes under data confidentiality. Some of the domain portfolio for EDS, engineering, design and simulation. We are doing multiple FE analysis like vehicle safety, durability, NVS, CFD, and many more, in which one of the vertical is manufacturing process simulation. In forging, I will talk mostly about the forging here. In forging, we have given multiple service in various domains, not only in automotive, but in defense, off-road, nuclear, energy, marine, aerospace, even in healthcare. So those are the parts which are shown on the screen, which are designed and simulated by us, and solutions were provided to the customer. Some of the few esteemed forging customers are displayed here. From small scale industry to the large scale OEMs are our customers. Even government organizations are also a customer to whom we are serving for. When we see the conventional method of product development, concept or the product design was freezed. Later on, its structural or FEA analysis were carried out, and its process simulations were carried out to freeze the tool dimensions. Those tool dimensions were manufactured for taking the further production trials, and then the final assembly was done. So this is the phases of the product development. But in today's scenario, all those functions are carried out by different organizations. So the concept and design was done by different organization, its FEA was done by different, and further all the processes were done by different organization. So during this process, all the data loss or the information which has to be carried forward, which was not passed on to the next phase of the chain. So here the data loss was much. Because of that, multiple defects or multiple problems are faced by the manufacturers. So some of the forging shop floor problems are displayed here, which are having fill-ups and underfillings. If that underfillings has to be filled, then excess material was used to fill those underfillings, and that excess material will also shoot up the tonnage requirement and breakdown of the presses or the tools. Faults and labs are the major defects which may fail the complete component in its field applications. Tool and die breaking or the cracking is the major phenomenon. Tonnage prediction is also one of the factor where a component which will be forged has to be undergone some design and simulation activities in which we could able to find the correct tonnage requirement to produce that particular component. If that is overutilized, then we can change the equipment and the capacity. The grain flow is one of the important parameter for getting a component strength. So the correct grain flow inside the component is also important to check, so that the component which you are delivering it to the OEMs has to pass certain testing conditions or testing criteria as per the standards. Trimming and heat treatment is also one of the issue faced by the forging manufacturers. When we give a challenge to the forging community, as I am going to talk on the lightweighting, many of the industries are moving towards the manufacturing of economical vehicles, means EV and alternate fuels, as sir has already shown some light on the EV. The components which are going into the vehicle has to be so light so that it will give required strength, as well as it will give some good average or mileage for that particular vehicle. So many R&D processes are going on in the OEMs, where the component itself, how can it be, how the design has to be changed, and component will be lightweighted. So those R&Ds are also going on. alternate materials. Many of the researchers or metallurgists are working for combining two materials and having multiple strength kind of material for their respective applications. So by changing only a material is not suitable for particular component. It has to be checked from the design point of view as well. When we talk about the material and design change, we also have to look for how that particular component can be manufactured by using an alternate modern techniques. So all these 3 points, I will show it in my next subsequent slides with case studies. So keeping all those points in mind, the manufacturer, forging manufacturer also keep that mind in, also see for getting a higher forging yield with the higher tool life. Also for the higher productivity and material strength. But he also need to be checked for lowering the energy consumption, emissions and production time and cost. Why we need lightweighting? It benefits of lightweighting vehicles. First, it improves the fuel economy, correct? Then your cost of traveling will be less. Your reduction in GHG, means greenhouse gases emissions, will be less. As your vehicle is so light, so the reduction wear and tear, its maintenance of the vehicle will be also less, even if you include the tires and all. We can increase the payload capacity and improve battery life in electrical and hybrid vehicles. So those are some of the requirement of the lightweighting and the needs. When we see the materials, the existing materials which we are using for vehicle building, those most of the time steel, cast irons and conventional polymers were used to manufacture all those vehicles. And now the industry also looking for alternate materials like titanium, aluminum, magnesium and other composite materials. Why those are used? It increases overall efficiency as well as safety, strength and performance will not hamper by changing the component design. And it has significant potential to reduce overall cost of the system or assembly. Who drives that? By using the need of alternate materials. One is abundant availability of those materials. If you say the aluminum, it will be recycled multiple times. It has a superior aesthetic look and feel. It has a high strain to weight ratio and excellent weather resistance, and it has prolonged life. So all these benefits if you are getting, then why can't you use alternate material for your components? I will show some case studies for all those materials and processes which ARAI has done with the customer, and they have got very good benefits. Let's see for the aluminum. Aluminum is basically used because of its lightweight. 2 series, 6 series and 7 series are the common series which are used by the industry. These are some of the examples in which you can see a complete bus structure was manufactured through extrusion, and it has joined through some gussets. So because of earlier, the complete bus structure was manufactured using the steel extrusions or steel bars, which is weighing some X. So that weight reduces its efficiency, or the vehicle efficiency. So we have completely manufactured the structure. We have designed along with the OEM, and complete bus was manufactured for the EV and alternate fuels. And this bus reduces the weight of by 40% if we compare it with the conventional buses. And it has also increased its running efficiency and reduces the travel cost. You can see we have also designed a gusset, I think, yeah. We have also designed a gusset to connect those pillars or the frames with each other, so that no rattling sounds or no rattling sound from the bolts connections, rivets connections, those should not be there. We have also designed these levers, pistons, and these footrest and brackets for various OEMs. We sat with them, we have checked the design, we have modified the design keeping in mind that aluminum or whichever grade we are going to use in mind. So depending on that, we have done FEA analysis first for considering those design changes. We have finalized the design, and then it's further process simulation and finalizing the tool modifications. And those tools were used for the further production trials. Another one example for aluminum, you can see a drive shaft which were used for the power transmission from engine to the wheel. So this is one of the fork which was used for these power shafts. Okay, so we have designed. Currently, the steel is the material which is used, but we have converted into the aluminum. Of course, by changing only material is not suitable, it will fail. We have changed the design and its dimension depending on how much power need to be transferred from X to Y place. So with this, we have, after this finalization, we have carried out its forging process simulation. We have finalized its number of stages required to produce this component. Its tool design we have finalized, and later on those are manufactured and assembled in the vehicle. This was done for a small commercial vehicle, and it has passed the criteria. You can see the weight difference, the component weight with respect to the steel and the aluminum. It has reduced from 60. It has reduced to 68%, and the complete whole assembly was reduced to 65%. So this was the benefit what industry is getting. If you see the next example for connecting rod, this is one of the connecting rod for small genset engines or two-wheeler engine, you can say, where a component was, customer is not having any kind of drawing or so. He is having only one physical piece with him. We have scanned that, we have redesigned or reverse engineered and made a CAD out of that. We have, we did some changes depending on the material. We further gone for the forging die tool design. We have manufactured that, and then the production trials were taken, and you can see how closely the simulation and the physical results are matching. So with this, the reduction of the component weight we have achieved is 30%. Of course, you can correlate with the cost benefit received by the industry. Now the next material is the titanium. Titanium, alpha alloy, beta alloy and alpha beta alloys. All three alloys are different, behave different in forging. So all those titaniums are used because it is having high corrosion resistance, it is non-magnetic and having low specific density. It is having high strength compared with aluminum also. So those are used mostly in the aerospace and healthcare applications also. So this is one of the turbine disc. This is used in the jet engines. So earlier this disc we are importing it from the Russia by paying huge money, but now we are manufacturing it in India under Atmanirbhar Bharat. So we have along with one of the organization, I will tell Midhani is the customer. So along with that we have modeled the tool design in such a way that this titanium grade can be manufactured considering their existing setup without hampering any kind of their existing setup. They have also established the isothermal forging. So you can see the isothermal is the keeping the same temperature of the billet and the environment to manufacture this kind of components. So the isothermal chamber has to be mounted on the press and then the forging will take place. So you can see the discs were forged and those are installed in the aerospace applications. So this was the first isothermal process established in India, and those dies and the process was done by us. The defect-free components were get produced and all the dimensions are within the limit. Now the world is also moving further lightweighting. So the magnesium is one of the material. So magnesium 3 series, 6 and 8 series means AZ8, AZ80, AZ60 like that. So those series are also coming into the market. Many of the aerospace components are manufactured from this magnesium and now it is coming into the automotive applications. We have carried out the process simulation for oil pump disc again for the aerospace application, and we did it for flashless forging, means there is no any kind of wastage coming out of the component. You can see this is the final component which was forged. This is the flashless forging we have carried out, and this component was defect free and it meets our component dimensional criteria. Now if we move to the from material, if we move to the processes, what are the lightweight done from the process point of view? If we change the process and accept the ring rolling applications, this is one of the example where these satellite launch vehicles, the propellant storage tanks were produced through these rings. So earlier a complete square block were ring rolled and various wastage was there through machining the final shape was derived and then that was used for the storage tank. But we did some changes into the process where two components were produced in single ring rolling. So here during this ring rolling, two components are produced in single go. So here the productivity has doubled. Also the 40% yield improvement was achieved and 496 kg of aluminum was saved. So this is the big benefits we are getting, and we have served this for Mangalyaan, Chandrayaan, even in Gaganyaan. There are many products for titanium and all, we did it for them. Use of orbital forming. Orbital forming is one more process through which aluminum wheels were manufactured. You can see a billet, hot billet is converted into the aluminum orbital forming, then piercing, and then further spinning, and then final machining. So this is one of the process chain in which orbital forming is used to reduce the input weight material so that you will get a light weighting as well as you will get a very good strength during its forming because of the grain flow inside the component. So its tool design and process design was done by us. Cross-wedge rolling. Here in India, cross-wedge rolling, less number of people know this technology. This is the technology where a hot billet was used to produce a final component, a round component of course, for their final product, or you can use that as a preform for its next operation, finisher operation. So this was produced with the help of a round tools. Okay, so in single rotation, one component was getting produced. So you can see how this tool was rotated in 360 degree and one component was produced. So those components were used for further machining or further finish processes. So use of these kind of processes for your components is very much needed. Here, of course, in a single go, one component is getting produced. So the productivity is getting higher. Also, the material is also saved by 10%. So these are some of the benefits for which the industry need to cater all those processes and use into their existing components. This is one more example for flashless forging. This is the crankshaft for two-wheelers. So one two-wheeler is having two crankshafts. So the weight, which is input weight, which is used to manufacture a single crankshaft, earlier it was 2.26 and having a 94% of forging yield, and remaining percentage is the wastage. So we have converted their design without hampering their existing setup and converted into the flashless, where the input, whatever input weight you are using, that will be your final component weight. So those are exactly matched. Means garbage in is your X weight and final component weight is yours the same weight. So there is no any kind of wastage. So here 99% forging yield were achieved, and we have saved 100 grams, almost 5%. And if you see the benefits, cost benefit, we have approximately 50 to 60 lakhs per year was saved. Also, the forging yield was improved from 94 to 99%. since we are not using a trimming and post wastage removal operation or the machine, so the kilowatt or the energy used to operate those machines are also reduced. So these are some of the benefits. You can see how those are manufactured without hampering any kind of struggle. So all those are manufactured. After manufacturing, those are also machined well, and the final component were produced. If I summarize my slides, then lightweight manufacturing of component is a reality either by changing material, geometry, or the process without altering the component's strength. Okay. The modern technologies like computer simulations could capture the defects, helps to arrive at optimum forging process with no forging defects, which give benefits of reduction in time, cost, and material wastage, and improves your product quality. It is encouraged to use modern manufacturing techniques like flashless forging, cross-wedge rolling, reduced rolling, ring rolling, or orbital forming to arrive at lightweight forging processes. Thank you very much for listening my presentation. If you have any queries, please do let us know. These are my contact details. You can take a photograph or okay. Yeah.
This is Sanju Tiwari here from Bhalerao. I recently met your team members in one of the exhibitions in Delhi, concluded, and I understand that you have inducted a few new testing setup at ARAI. It's just that I would like to know how are you going to ensure that the testing setups are fully occupied and they support the required organizations in time?
Of course, they will support. They are for you only. And
in time is the
correct
catch here.
It depends on what kind of testing, physical testing. You mean to say physical testing?
Right. Like for example, long back, this halt test used to be there, where we used to do the vibration test and other stuff.
Okay.
So what happens is normally the time duration, the entire time that it takes for your people to respond and then give us a slot. Maybe I would like to see a bit of an improvement on that front. Nothing else. Otherwise,
Sure,
we do know you. We have your support.
Yes.
Thank you so much. Thank you.
Yeah.
So the strength and the weight analysis was presented, but then just for curiosity,
yeah.
What's the cost that changes, when the lightweighting happens? Because at the end of the day, when we have to bring a lightweight component, then it needs to have a cost-benefit analysis as well that needs to be presented, right? So if a steel component is costing X, and then an equivalent aluminum component, what is its cost? So that there is an increase in cost from a component perspective, but then there is also benefit that is coming from reduced weight and so on and so forth. So is there some analysis that's made between cost analysis?
That cost analysis will be done after the manufacturing of the components. So this cost analysis, what I'm showing on the screen, that 50 to 60 lakhs per year, this is just a manufacturing of this particular component. If the existing with flash component was manufactured, let's say for 1 lakh pieces per year, then if you reduce 100 gram and if you multiply that with the steel price, this is the cost. So that cost you are saving from.
I was actually referring to the aluminum components that you shared in the beginning.
Yeah, this one.
Yes.
Okay.
So there was one more example where there were like 60.
Yoke.
Yeah.
Correct.
Yeah, right here. Yeah, so weight reduction is almost 68%.
Correct.
Which is an extremely good number to show.
Correct.
But then it's the component which was steel. What was its cost versus what was the cost
Correct.
of the
Of course,
aluminum component?
steel cost is much cheaper than the aluminum cost. Correct. So if we save the material, and if it is means the material saved from that particular point of view, if you see, and the end user is getting benefit out of this assembly weight. Assembly weight is also saved by 65%. So of course the OEM or who is going to install this assembly into their vehicle, he will look for the cost benefit he is getting if he is comparing his vehicle with other market players. Then of course this cost is much lesser if we see it from the most top side. Then this cost, the component cost is much lesser compared with the complete vehicle or the assembly cost. The weight reduction, if you are getting into the single component, and if we compare with the assembly component, those.
My question was more as, if I have to make this as a business case,
Yes.
and take it to a customer and say that, this is a service that, we can offer as a lightweighting for your stuff. And then an example would be, here is a steel component which can become
Correct.
analysis, and the engineering process is all clear. But where the real challenge comes is, when we do this as an aluminum, obviously there are going to be process changes and all that. We're not even going over there. But the cost of the component itself goes quite high. So what I am actually looking for, Mr. Kumbhar, is how can we go and justify to a potential adapter that by going to aluminum, you have this set of benefits that you are going to get. Because at the end of the day, total cost versus total benefit, there needs to be a balance, and then if the benefits outweigh the cost,
Correct.
then addition is made to actually move towards that path. So my question is, has ARAI made any such analysis or made some certain templates or anything which can actually be presented to the adapter? Say, here, because of all these following reasons, you are going to get more. Component to component, it might be expensive.
Yes.
But looking at all these things, you are going to get something more than that. So is there some such analysis made? That was the question.
After this production, those analyses were not carried out because those are confidential matters for the opposite party. So they will not share those details, means commercial details much to us. So those studies were not done for this particular.
Gotcha. Thanks.
Maybe I would just like to add on to what you said just now, Mr. Kumbhar. So, as and when the weight of any part of a vehicle comes down, automatically the fuel efficiency is going to increase.
Yes.
So, based on this simple analysis, a detailed analysis can be carried out by the good organizations themselves also when they are working on any project. So, even if say for example, you're talking about 0.415 kg reduction, which is in percentage it is 68% on the weight front. So that is definitely going to add up to the fuel,
Correct.
benefit in the fuel consumption. The fuel consumption is going to go down. So I think at individual levels we'll have to carry out those analysis. Like you said, your end customer, they will never share the confidential data. Though even I would like to have that, have a look at the analysis. I don't think they would share that. Thank you.
Any questions? Thank you very much.
Right. Thank you so much, Mr. Kumbhar. That was an insightful session. I would like to call upon Mr. Abhijit Oak to felicitate Mr. Kumbhar. As we transition into the next segment of our summit, we are excited to present the Fireside Chat, an engaging and insightful discussion designed to delve deeper into the pressing issues and groundbreaking trends within the automotive industry. This session will be chaired by Mr. Arun Bhardwaj, the editorial director of Efficient Manufacturing magazine. He has a total of 33 years of experience in media, software, and the EV sector. He holds an MCA and an MBA degree from Delhi University and has worked with business houses in India, US, Singapore, and UK in various capacities. He has played a major role in bringing few key players to India to sit on the boards of various multinational companies while steering the growth of the industry. Please give a round of applause as we invite him on the stage.
So thanks again, and again the interesting topic of EV has come, no matter whatever it is. We talked about the production, the PLI, or the EV manufacturing by Shirish recently, and I think maximum number of questions has come for that only. So again we are here. What I feel that whatever the transition we have faced from lead acid batteries to the lithium or the forthcoming technologies, or in the drivetrain also, the motors, the controllers, major part is played by the software. Be it a firmware, be it a UI based, whatever data analysis we need is come from the software. So continuing in that trend, I would like to call next two speakers on this topic. One is Ganesh Pandit, who will share his views. He's director engineering from mobility group from Eaton, and he has worked with the GE and Mahindra group. And the next speaker will be Nesar Kalasur. He is DGM Technology, Strategy and Innovation at Bosch. And they both are the big players on this, and I would call them upon. I think first Mr. Ganesh Pandit to share his views, and then followed by Mr. Nesar Kalasur. Thank you.
If I can remove this cell, can I just? Do you have this one works? This won't work for me. Which one you want? HDMI or same? No?
Mr. Ganesh Pandit, Director of Engineering Mobility Group and India Innovation Center at Eton. Okay, let's call upon our next speaker, who is Mr. Nesar Kalasur, who is the Deputy Director of Technology, Strategy and Innovation at Bosch.
working at Eaton for last 19 years or so, and all the time with the mobility or the vehicle business group. Okay. With me, I have my marketing representative, Priyanka, and Chief Engineer Electrification, Guru Prasad. So certainly any questions, they are more than happy to contribute in addition to my views. Okay. So going to the topics, we'll talk on these topics, my views or Eaton's view represented through this presentation. Okay. First is, as you see on this slide, few trends in the vehicle industry. 24% of all the vehicles produced will have some kind of alternate propulsion by 2030. That's one of the things, very key driver. Number two, you still see, despite alternate propulsion, what you will have, close to 100 million plus vehicles still will be having IC engines by 2030. Third major driver where these alternate propulsion or electrification, all these areas are coming, is certainly the emission regulation. And the numbers represented here talk about heavy duty diesel engines will require at least 50 to 90% reduction in the emissions, what you see by 2025. And lastly, where vehicles are becoming more and more intelligent, which is represented by one of the comment here, is more than 200 million lines of software codes. Okay, that's what. So when you look at these major trends, with respect to that, as I will talk with the closure of this presentation, Eaton has a portfolio which is having quite innovative solutions which will help in fuel economy as well as emission challenges, which either improving the existing IC engines or for the alternate propulsion systems, whether it is any kind of EVs. Okay. With that little bit brief, let's understand additional details on what is a market scenario in terms of the proportional technologies. So if you see on the left-hand side graph here, it talks into three verticals: four-wheeler, light commercial vehicle, and heavy commercial vehicles. And what you see on this graph is close to 20% or so is what is represented. The first graph and the last vertical. That's what represent by 2030, 20% or so number will be the BEVs. However, at the same time, IC and the alternate fuels, IC with CNGs and LNG will have significant share growing from now. And still the pure ICE also continues with the technology advancement for the emission and controls. Okay. Now, what are the favorable for the IC engines and what are the challenges for the IC engines? Let's try to understand those. So if you look at the challenges, obviously emission control and regulations, fuel consumption regulations, improved combustion processes, what you need for the thermal efficiency improvement, and then lastly the new technologies which are getting introduced as a result of whether it is a BEVs, pure BEVs or FCEVs. Those are some of the challenges for the existing IC engines as it is to sustain or continue. Versus the something which is supporting, which will continue to be supporting for the IC engines is the commercial vehicle segments, where the first factor is the power output, which is required for the commercial vehicle segment. It strongly can be supported for the IC engine compared to the other technology systems. Number two is the durability and reliability. We all know the load carrying capacity, various duty cycle to which commercial vehicle segment is subjected to, very extreme duty cycle. IC engines will have better durability and reliability in that segment. Cost effectiveness and adaptability to the conditions where these vehicles will be subjected, that's where the IC engine will prove still better than the upcoming technology which are at a lower level of technology maturity. Which means IC engines will continue to have a dominant position in the traditional powertrain for at least for next decade or so. That's what the forecast talks about. Okay. Now, what are those emission regulations and what is happening with respect to the emission regulations? If you look at the four major regions, US, Europe, China, and India, if we go historically, certainly each region has its own regulations, how those were getting formed based on the available infrastructure, based on the technologies available. But as we go to 2025, 2027, most of them will have a very much converging regulations. And that's where what this chart represents. You can see beyond 2025 or so, almost each region will have more than 15% reduction in CO2 emission. That's what the targets will see. So everybody is almost converging, which means the technology required, technology solutions to meet those CO2 regulation, everybody will need to have it in place. Number two, even for the NOx, by 2027, if we see, all these regions will have close to 70% plus, 75% plus reduction in NOx target, which means also again for the NOx, whatever technology offerings required, each of the region will need to put those offering into their markets, into the vehicle in their market. Okay, so globally, every region is, the regulations are converging by 2025, by 2027. Now, with respect to this as a background, let's try to understand where each of these engine technologies, whether it is a biofuel, hydrogen ICE, hydrogen fuel cell, or a battery electric, where they stand on two primary criteria. One, emission. Second, total cost of ownership. And each of these two buckets, there are further categories like CO2 or air quality and total cost of ownership, definitely by efficiency, initial capital expenditure, or the infrastructure cost for the running operations. The color codes on this slide, high performance versus low performance with respect to that criteria is what is represented here. And at a broad level, biofuel will have benefit of the capital expenditure or the operating cost very much similar level what today we are. So not a significant initial investment or running cost investment required. However, if you see the disadvantage is in terms of the efficiency levels, it's at minus close to 20%, which is not necessarily a great efficiency level when we consider well-to-wheel efficiency levels. Okay. If you go to the extreme end, battery electric, there you get a very good well-to-wheel efficiency, close to 75% or so, 75 to 85%. But the disadvantage in that case is definitely the initial investment on capital as well as the infrastructure investment required are high. Very obvious, because the technology maturity in this field is not necessarily as great as what biofuel and synthetic fuel will have advantage because of the proximity to the conversion from IC to these categories. Okay. Certainly hydrogen fuel cells fall in between these two categories where its efficiency levels are better than the biofuel but not necessarily as great as battery. The infrastructure required there are also little bit more than what is required for biofuel or synthetic. Now with this all background, what is going to happen to the potential forecast if we look from now till 2030? So this is, obviously there are multiple scenarios. If you take an average or the base scenario, it talks about close to 8% battery electric vehicles by 2027 or 14% by 2030. If you go into the commercial light vehicle segment, that forecast can be somewhere between 32% by 2027 to close to 44%. However, these are maybe average representative numbers. If we look at the rate at which infrastructure investments are happening or the high cost of initial investment, if those are not favorable, then this forecast can drop by 3%. But if regulations and the technology advancements goes faster and these factor becomes favorable, this can go plus 5%, the penetration what we are shown here. Similar is the case for the light vehicle. You can consider this will drop down by 3 to 5% or increase by 3 to 5%, depending on how is the supply chain or the regulation infrastructure cost as key driver, or in the previous presentation you heard about availability of the battery related rare earth materials and so on, right? So that will drive this plus minus 3% or plus minus 5% with respect to what is forecasted in the industry right now. Having said that, how companies like Eaton, who are tier 1 supplier to the OEMs, how they are positioned. So I would specifically share views with respect to Eaton's product offering. What we can do is one is the base engine, there can be changes to the compression ratio, there can be changes to the fuel or some of the novel IC engine concept, and that can help to improve NOx or CO2. The boxes represent here, like obviously the NOx and CO2 improvement, as you see pure battery electric vehicle highest level, that's where the all 5 dots there are green, which shows the you'll fully achieve what is desired level of reduction in NOx or CO2. Versus if the green circle is only 1, it is a lower benefit. That's what it means that way, okay? So the initial base engine improvements can give some benefits, and the dollar cost on a relative scale where it is for those investment is shown, and the tick mark there kind of representing Eaton has that offering, or Eaton can contribute to OEMs to make a difference on these technology solutions to achieve NOx or CO2 reduction. The biggest play for Eaton is VVA, which is variable wall actuation. Obviously, all of us understand more you control the emission at the combustion level itself, that's where you will have bigger benefit. Versus the other method is you capture it into the after treatment system and reduce it. Okay, so Eaton has significant play on the variable wall actuation, whether it is a cylinder deactivation (CDA), late intake valve closure, or early exhaust valve opening. Through these areas, the whole combustion process can be controlled or can be influenced to reduce the emission for NOx and CO2. These are the places where we have the offering where again the cost associated, because what is happening here is you're going to the wall opening, wall closure timing diagram and adjusting there, and accordingly you are managing the fuel injection, and that's how you are controlling. So the cost associated with this technology is not as high as what you see the bottom 3 rows in terms of the investment or the cost associated for those changing to that level are very high. Okay, so those are the near term where we are finding trends where OEMs are adopting these technologies, CDA, LIVC, EO, to reduce the combustion beyond base engine improvement. So at the source level itself, control the combustion or reduce the combustion. Okay, the next level is about the after treatment. Okay, in the after treatment system, Eaton's focus is more on the last category, which is about the e-heater, where you can really, at the after treatment, one of the most important topic is at the very early stage when it is not enough heated up, okay, or in the extreme temperature condition, the emissions which are coming at that, those are the ones which becomes very difficult to meet the regulations. And with certifying the vehicles for the emission regulation based on real world driving cycle, we need to meet the emission even in those very, very small duration events in the beginning where it is not enough heated up or extreme duty. And in those situations, the e-heater just before the after treatment is where Eaton has a play. Lastly, electrification areas, whether it is a 48 volt hybrid or the fuel cell or battery electric vehicle, Eaton have its own portfolio of product like power distribution and circuit protection, or 48 volt system, DC-DC converters, inverters, or many other in terms of electric vehicle gearing, electric vehicle transmissions. Those are the areas where Eaton plays, and this is how it can help on the scale of NOx and CO2 reduction and the costs associated with them. So that's some additional view with respect to what technology offerings are in place, starting from base engine improvement, controlling the combustion itself to reducing the emission in the after treatment level, or totally going into the electric vehicle. With that, this slide kind of represents in 100 plus years of technology focus product evolution where Eaton stands on right from internal combustion engines to electric vehicle, what are the product offerings. This map can be applicable to almost, I think, all or majority of the tier 1 suppliers or OEMs who have a significant share in the market. Because what everybody is trying to do is having a fair play in all these areas, whether it is IC engine, hybrid, or the electric. Because the forecast in what will work in long run will keep on fluctuating depending on geopolitical scenarios. Okay, who will have the rare material, who will put what regulations, what are the import-export duties. So OEMs and tier 1 suppliers like Eaton are positioning in all three areas the technology development so that they continue to contribute to the end customers in terms of the best vehicle technologies what they can offer while ensuring the regulatory needs are met. That's what I have for sharing my view as a Eaton representative here. Any questions for me, for Priyanka, for Guru?
Thank you so much, Mr. Pandit. That was an insightful session. I would like to call upon Mr. Sanjay Jadhav to felicitate Mr. Pandit. Thank you so much. Let's invite our next speaker, Mr. Nesar Kalasur, who is the Deputy Director of Technology, Strategy and Innovation at Bosch.
Thank you for having me here. My name is Nesar, and on behalf of Bosch, we want to present some of our views related to the technology trends that are marring the automotive industry. By and large, I majorly endorse the views that my colleague Panditji just expressed on the stage here, and I'll just try to pan a few more views and perspectives that we would want to put across here. And but just before I commence, let me briefly contextualize you with the ecosystem in which we all are operating, and by touch basing a few macro trends that are landscaping in India as such, so that we see it from a technology lens and what are the key drivers for it go forward. So to do this, we see the emerging trends through a couple of lenses. One is the mobility data. The second is technology, and since it's a forum more related to manufacturing, so I also give few snippets that could also touch base manufacturing. Like my colleague Panditji just shared a few minutes back, that major drivers are coming from the overall geopolitics and how the globalization is panning out. And if you go to see on a large scale, the GDP improvisation or the development on a larger scale across the continents is majorly marred by geopolitics and protectionism policies. And this is emanating in the form of newly emerging power challenges, which are centered around emerging regions. Take, for example, China and the anti-China policies, say, for example, the anti-dumping duty or the IRAs that are imposed by sanctioning countries as such. So this has a predominant importance in how technologies will flare up for the future. So while this is a global annotation, let me also give you certain data points as a strategist about what are those data points that we look across when we are mapping out our technologies for the future. And this predominantly has an importance about how it looks on an India map. So if you see India predominantly today, 1.4 billion people in terms of population. We are the 5th largest economy We've touched $3.7 trillion last year, and we'll quickly call, and the vision to go to the $7 trillion economy by 2030. When we speak about automotive, we are already the third largest in terms of car market, with approximately 20 to 25 cars per 1,000 people, which just shows the propensity in which we can still grow for the future. When you talk about the per capita consumption in terms of the classes or the strata in which the Indian consumer is evolving, so the per capita income is also moving on the higher side, which gives a better utilization or the spending spree. An interesting part of the demographics for us is how the STEM population, which is the science, technology, engineering, maths, in terms of the educative quotient for us is growing, where 32% of the world's STEM graduates are emanating out of India. And as we say, the digital penetration of India is much well known. I will not rant it because you could have heard it from different forums. It's much about 900 million internet users. You have this 1.2 billion mobile subscribers. You have the JAM Trinity, which is the Jan Dhan Aadhaar mobile. That's all the digital stack that has been put up for India. But much more important is how this digital ecosystem is really helping take off the overall technology landscape. And as we speak, the third largest ecosystem for curating startups is getting born in India. And hence, it's a nation for around 100 unicorns that get born recently. And if you pan more further, we are also the third largest energy producer in terms of fossil, non-fossil fuels going further. In terms of the infrastructure, today we are the third largest in terms of road network, to the tune of producing or laying 10,000 kilometers of stretch of roads every year. And to equalize this, when we say to our German counterparts that we lay roads to the quantum of one autobahn every year, that's the quantum in which we preach it to our German counterparts, because they are not able to understand the mammothnesss of growth in which we are scaling up our infrastructure. We are already the fourth largest rail network in the world, which is much known, but the important aspect what I wanted to highlight here is it's 90% already electrified. The last, we are also the fifth larger manufacturer in terms of GDP contribution, and that's the focus of the government and how all the three cylinders of the manufacturing GDP grows, out of which manufacturing is one of the key cylinders for the drive growth. So having said this, we turn our attention to all the three sectors which are basically related to mobility. And when we say mobility, we see it from a couple of lenses, at least from a strategist point of view. These are predominantly two annotations. One is called as the BPKM, that is the billion passenger kilometers in which people move. So how people move and how goods move, and something which does not move, which could be stationary objects, which could be related to your power, telecoms, data centers. These are all stationary objects. So when we say these two annotations, I'll represent this in a visual which you can see on the screen. This is called as the BPKM, billion passenger kilometers per year. And another annotation is BTKM, which is the tonnage freight, which is billion tonnage per kilometer. So that's the first line, which is on the goods. You'll see how it is distributed over the three modes of transport, basically the water and air on the first side, the railways in the center, and the roadways on the extreme right. The two bubbles indicate the timestamp, which the blue indicates which was in 2021, and how do we see the forecast in the outer years of 2030. So what you predominantly see is the growth in each of them, specifically in the railways. If you see the bubble growing from 30 to 40%, whereas the roadways will shrink from 63 to 51%. So while that is in percentage, it's not true for absolute value. The absolute value still remains, because much of the heavy freighting, say for example cement, oil, could move to the railway sector. So that is coming up in terms of dedicated freight corridors, or even the cars transportation moving onto the railways. This is how we see in terms of the goods moving. If you see the people movement, which is the BPKM, the overall BPKM is very standard across taxis, rickshaws, cars, scooters, railways. And again here we see the similar trend across all the sectors showing an upward trend. The railways being static because railways are predominantly for goods. The people are really subsidized in terms of the revenue it brings in, and we see a marginal dip in the roadways as well. An important data point, if you'll also see in the bottommost strata, is that 74 or 3/4 of our freighting needs of the country are on long freighting, because as a nation we are distributed amongst as a producing state and a consuming state, and this is where the distribution in terms of freighting lies. And here we see where mobility gets impacted in terms of the heavy commercial usage, hub and spoke models, or if you take all the policies related to Gati Shakti Yojana, national logistic policies, all these will be curated towards this. And this specifically because the contribution of this long distance freighting is heavily induced into the GDP. So while we talk about the contribution of logistics, it's around 14% to the GDP, which is not really at par with the global average, which is just close to 8 to 9%. So that's how the government missions towards reducing these inefficiencies in the system towards logistics will also cause an impact on the mobility side. That's the reason why also we look at this very closely as a strategy. If you also see the number of kilometers that are clocked by the freighting industry, today it's around 200, 230s as such kilometers per day. But if you beam at the type of highways, the freight corridors, the national corridors which are being laid out, we see the average speed increasing to 300 kilometers a day. And even with new logistics startups like delivery, e-commerce coming in, this will also, with around the clock drivers, you also see it to going to around 300 to 400 per kilometers a day in terms of express freight. So this has a lot of implication on mobility as such when we look at the emerging trends that will come and hit the mobility side. On the passenger side, we will see that there will be approximately 1.5x increase in terms of passenger traffic that will increase over the outer years of 2030. And this will be predominantly by road transport as well as by buses. And the ratio between intra-city and intercity will be around 60 to 40%, 60s to 40. So these are the primary data points in terms of how India moves is to be represented, and a part of this really comes and hits the mobility side. If we pan in more into now the technology strata, and we see how it really touches the mobility side. We as Bosch, with around 100 years of existence in India, are also sensitive to the societal needs of the nation. And as we commemorate this milestone, we understand the regional pulse very well, and we have an endeavoring vision to make driving which is really stress-free, accident-free, and emission-free. So these are our three cornerstones across which we have a business as a purpose. Having said that, I will also come out to express our views on how do we see the powertrain trends, and largely just duplicating you, Ganeshji. A few of the trends and the numbers are similar to what you see. So if you map it on a global scale, in the outer years, one among three cars or three vehicles is necessarily going to be an EV. So that counts to be around 30-35% of an estimation. It has a lot of assumptions built behind it. Say, for example, how the infrastructure comes in, the protectionism policies, the geopolitics. If Trump comes back to power tomorrow, then all the equations change. So is again with Modi 3.0. So having said that, it is hinged at a couple of trends which have to be closely monitored. But what does this mean for India as such as a region? We also see that this will be a multipolar fuel mix that will coexist for longer years. And while the EV spree is true to happen, the conventional technology will still exist till the outer years. So even if you talk about 30% of EV in the outer years, where will the other 70% come from? So the other 70% does comes from your mixed fuels, which will be gaseous fuels, which is an interim transition to the EV. You will also has flex fuels in terms of E20 contribution into the fuel, and thereby also increase based on the production of ethanol, and thus you will have a multi-fuel existence going forward. So predominantly, if I take a very transformative or a very non-conservative view, we still look at 30% EV in the outer years, specifically for region India. And the key drivers for this segment, when I say segment, EV is always a poster boy for a car, not a truck. And it will be for two-wheelers, three-wheelers, but predominantly the key factors for them could be the falling battery prices as they soften for demand, or as the efficiency set in. So we are looking at sub $100 per kilowatt hour as the prices go forward. Similarly, there's a lot of work also happening in different cell chemistries for battery, which will also differentiate the prices between the choice of a battery between an LFP, an NMC, or sodium-ion batteries. The TCO, making it favorable, is an important thing, because today the TCO is mapped with the subsidy. An important thing to be seen is what happens to the business economics without the subsidy as soon as the critical mass for volume reaches. And of course, the infrastructure is a common denominator that cuts across many of the fuels, including H2ICE as well, which is seen as an interim fuel towards the fuel cell or pure green H2 for the long haul freight. I will also take a glimpse across how the flex fuel or the blend fuel will also emanate for India. And our point of view is that in terms of the supply and the demand, the execution side looks to be much on track. But as you soar to move the blend or mix beyond E20 towards the vision of going to E80 or E85, which is the blend of ethanol into pure fuel today, into the likes of other emerging regions like Brazil, it's still a distance away. So there needs a gear shift that has to happen if the blend has to be increased in percentages beyond E20. And as we speak this, I've been hearing this conversations in morning about the EVs being the green fuel, the CO2, and all the narratives that were laid behind us. Of course, that's an important point. But if I give you a data point in terms of the NOx versus CO2, the contribution of transportation into CO2 or global GHG is as less as 9%. The highest contributor is coming from agriculture, industry. And with whatever tech you use to decarbonize the transportation sector, the max advantage that you will get in the overall contribution of CO2 GHG is going to be 3%. So then this leaves us to ponder then what is the real reason for us to push these CO2 intensive technologies so further. And the prime driver for this, which we have not talked about, is the oil import bill for India. So even as we stare at it, we import crude oil and LNG worth $122 billion. $122 billion is a huge amount. And with these transitionary fuels, even if we are able to cut down to a few $billion, it's good enough to build schools, it's good enough to socialize our health reasons, and it's good enough to add food security to the nation. So that's the vision in which the government works to reduce the trade deficits in terms of crude oil. So yes, CO2 reduction in terms of all Paris Climate Commit, this commit, that commit is important, but the major driver, the standing impending need for us today is to reduce our oil import bill. And to do that, bring any tech is okay. You add E20, you go to gaseous fuels, you go to LNG, you go to H2, is all okay. Any reduction is always a welcome move. So that's the point I wanted to leave you with. Moving further, as we see the tech trend shifting, it's typically an S-curve into any product regime. And you have, since history or since ages, a particular S-curve of the product, which is typically, till today, basically based on fossil fuels, It is also was on embedded software. I also heard Ganesh ji quoting about 200 million lines of code. So that's hardwired to the product today. And you will also call about the minimal UX which was there on the car today, car before. When I say minimal UX, is that even the instrument cluster or the infotainment was accessory fitted. The AC came as it was not a default option. So as you move forward, what happens to the S-curve in terms of the product tech in the car for the end consumer is blatantly changing. So what happens going forward is we see tech which is disrupting the traditional S-curve, which is the green line. So the green line comes in terms of non-fossil intervention. It is coming from more inclusion of software into the vehicle, which is called as the software-defined vehicle. And it also calls for enhanced, elevated user experience in the car. So today, when you make the choice of the car today, you don't go by the choice of CO2, like how my colleague quoted in the morning, that I buy a two-wheeler just because it is not giving me exhaust. You buy a car today really because your children want the sunroof on the car. That's your first criteria in which you choose the car. So the second reason why you buy the car is when you sit inside the car, that's the cockpit feel which you have in terms of the phygital experience that you get. So these are typical trends which are overtaking the choices of torque, engine speed, horsepower, which we previously used to claim as key criteria for us to buy the car. So that was a point which I wanted to leave in terms of how the S-curves are getting shifted. Few will exist, but that's how technology shifts will have a paradigm of. I also wanted to quickly touch the trends when it was related to automotive beyond fuel, because this is one which is glaring the industry very strongly, and that's about software-defined vehicles. And we had an age where it was all mechanics. The mechanics moved to electromechanics, and now there's a shift into software. So why is it such a big thing? And to explain you this, I have a parlance in terms of the mobile phone industry. So if you've all seen the previous, all of you will have used the Nokia 3310. It was a simple analog phone, black and white screen, keypads, and there was a software which was hardwired to the hardware. And you don't have apps. It was a basic feature phones. The features came with the hardware, and there was no autonomy that was with the user. As we shift downwards, you will see when the feature phone translated itself to a smartphone, it came with higher computing capabilities. So it had a processor on board, you had a software on board, and then you were able to do all your apps. You were able to play around it, and that's how the same scheme of things is now going to be in the car. And what really it means is that the car will have a processor, and then it will also come with the apps in the car. So for example, tomorrow there will be a use case where you can also subscribe to a higher torque for 2 hours, and you can unscribe it. So that is how the car will emanate. So quickly moving, this is how the technology curve we see would catch up, and few of the technologies are just in the startup spree. Some have matured, and if you see the center cluster, which is strongly precipitating, that is all towards the software electronics. And we at Bosch are also organized ourselves towards this way in which software and the domains will get verticalized, not only in verticals but across horizontals, which is on the car, which is on board, off the car, which is on the cloud, which is off board, and this is our tech stack in which how we will create market positions. Lastly, closing on a topic which is just related to the manufacturing, I'll also give you a parlance about how this shift in technology on automotive is also having a bearing on the manufacturing. And if I just chose for a few corner modules, it's basically on electrification. Semiconductor becomes manufacturing intensive, where the hardware also outbeats the software. And of course, you have software, data, and AI, and finally the mindset. To give you a quick glimpse of this, when it's EV, you can't afford to miss Tesla. And if I talk about Teslafication, here are 2 examples which I wanted to quote just for your reference. So you take the case of a Tesla with its BIW or a body. along with the mass of its battery, along with a legacy OEM with its BIW and the whole fuel system as such. There's almost a 14% reduction in weight as compared to the legacy OEMs. And this comes not only in innovation and technology of the product, but also in manufacturing as a process. So manufacturing plays a very strong role in the innovation, which is many a times underplayed in the product innovation. So if you see Elon Musk, he also democratizes the technology which goes under the hood of the Tesla Model S. Two data points to also refer in the manufacturing is the Giga Press. Today, if you see, it presses 80 kg of molten aluminum. I heard you speaking about the lightweighting. It presses 80 kg of aluminum into a press, and it eliminates 800 weld joints, which would be traditionally required to make a car. So what does that mean? It injects aluminum at 80 kgs aluminum, and the aluminum does not, and they have invented their own aluminum grade, which does not require heat treatment. So it presses, and the car is out with only 3 parts, and you only fit 3 parts. And that's also what is called as the unbox manufacturing model. So I go beyond manufacturing now into the assembly process, and the assembly is also an unboxing method, which calls about only 3 parts to be fitted, which also reduces the overall intensity of operator movement by 44% and the 30% space and time efficiency which comes along with it. So that's a very radical approach, and which is not there in the traditional OEMs to talk about. If I talk about the other examples of software, data, AI, this many of our Bosch plants have also been started utilizing, and just to quote a few of them is all AI-based sensing in terms of the electrical motor technology, where you have the copper which has to have maximum density, and we have optical synthetic images which are induced to have maximum efficiency in terms of draw for the copper wires that are put in our motors. I end my message here with a message to germinate in your mind that what does it take us to be there? It's basically the mindset. And the mindset is purely resonated by this particular image, where you see Tesla far behind the curve, and this is where the catch-up games for many of us is actually where. And this predominantly requires us to learn, unlearn, and really try quickly and fail fast as we move towards the next era of product development and manufacturing. So thank you, gentlemen. This was all that I had to leave you with in terms of industry trends that are touching our automotive industry, and certain facets for you to look at it. Thank you. If there are any queries or questions we could take it offline. Thank you so much.
Thank you so much for that insightful session. I would like to invite Mr. Arun Bhardwaj to come on the stage and felicitate Mr. Kalasur. Thank you so much, sir. I understand it has been a long day, but coming to our final presentation for today, please join me in welcoming our next speaker for today, Mr. Sandeep Madan, who is the mentor and head of technology business incubator for iCreate. His experience in the industry spans over 3 decades. He has played several roles in leading BPO, telecom, and IT industries. He is currently associated with iCreate, which is India's only non-academic institution dedicated to fostering startups based on tech innovations into successful businesses. He will talk on the topic of the EV value chain in India and the contribution of startups. Please have a round of applause for him as he comes on the stage.
Not easy to be the last speaker for the day, and after
realities. I will not delve into it doesn't matter. Okay. Otherwise I'll end up blocking the screen. That I was doing so that I could move. Okay. So I am not going to talk much about numbers because I take it that in some form or another you are aware, and numbers will only make it look good. So broadly, you are all aware of the EV value chain, and this is just my way of specifically classifying it. If we look at startups in the EV ecosystem, $2.6 billion have been invested in the startups in India since 2015, primarily led by original equipment manufacturers. Now that is news because one would expect VCs and others to be leading it, but it is the OEMs that have been leading the investment. Rapid technological enhancements will continue. I think the last two sessions have said everything that I need to say about that count. And in that context, the startups will continue to emerge. So it's going to be a reality. It's going to be something that is there. I want to take a minute and talk about startups. So this is an industry which actually contributed and generated an entire segment called the ancillary industry, going back decades. So this is not an industry that is not used to partnerships, that is not used to working with vendors, working with partners. This industry is more seasoned than most other industries are. However, the term startup creates certain jitters, and we shall address that as we move further. So startups in India have worked on controllers, a lot to do with software. We are talking about software, so most startups in India started working with motors, and there has been some good work done. There are startups making motors, smaller capacities, not the really large ones, and but a lot more innovative work has happened on the software part of it and the battery packaging, and then everything that goes along with the battery in terms of charging and so on. There is also work happening on intelligence and communication. I will broadly classify that into that data, into that user look and feel, the cockpit look and feel that you see in the car today. And gone are the days when you primarily bought a car because it drove well. Now the first requirement is that the car should feel well when you sit inside. It is a given. You take it for granted that the car will drive well. There will not be an issue. Okay. There is future, whichever way it goes, but will it come? It will come. I am not here in the midst a bunch of experts to guess when and predict when, but will it come? It will come. Working with startups, let's face it, there is an apprehension. Okay. There is an apprehension in terms of deliverability, dependability, maturity, survival. This from an industry that has worked with partners pretty much all its life. This from an industry that has always generated and helped thrive an ecosystem of ancillaries. So I have known both as a fact with my own association with the automobile industry as well as experiencing it from this side of the table and experiencing the hesitation with startups. So my opinion on that is that earlier when you had small and medium enterprises that were set up as ancillaries, they were primarily businessmen or people who stepped into business. A startup today, by definition of technology, is more of a tech entrepreneur, may not be a businessman, may not be a savvy businessman. So it's more tech there, and that creates certain jitters and certain apprehensions in dealing with startups. However, let's recognize there is an opportunity. There's an opportunity not to miss out on an innovation that is happening, because we have all seen in our lifetime certain companies disappearing. Tesla did not exist a few decades back. Kodak is a name in memory. We've seen it with Nokia, that was an example taken. And we've seen only because they did not recognize the innovation or they didn't see the innovation that was coming. There was no other reason. Okay. It wasn't bad business management, it was just bad, poor anticipation and a poor understanding of customer needs. You never know, a startup might offer you a game changer solution. And let's face it, a lot has been spoken about it, but technology, market, customer demands are changing. And they're changing faster than ever before. And there's nothing that's going to slow down the process. It's going to continue. So I'll call something the smarter way because I couldn't come up with a better term. Engage with a credible incubator. Okay. Do not, you're welcome to talk to startups directly. My suggestion would be engage with a credible incubator. And this is something coming from someone with more with industry experience than with incubation experience. My experience in the incubation ecosystem is less than a year. So throw out problem statements, give out problem statements, challenges that you may be facing or that you may be anticipating or you don't have resources to do or you don't have time to do. You never know, somebody might come back to you with a solution. Sponsor innovation challenges. There is a lot that happens under the heading of marketing and business promotion. This won't cost as much. It might yield you something good, otherwise it will only contribute to your brand image. Encourage. You could encourage, as industry captains can also encourage by helping mentor startups. Not just invested ones, but even otherwise mentoring startups, doing paid pilots with them. But again, the crux is really the first bullet, engage through an incubator. So let's step back and talk about what an incubator is. So the India startup ecosystem, I'll say there are about 1,000 plus. In fact, the number was about 1,200 plus. I just took it safer. About 1,000 plus incubators out there. Just as exists with your EV manufacturing, it's a full normal distribution. You have market rubbish to some absolutely great ones. It's a full distribution. There's a lot of government funding for funding support for early stage startups. There is today an established presence of venture capitalists in the country, didn't really exist 3 decades back. And there is an increasing participation from angel investors. Different reasons, some of it is opportunity driven, profit driven, but there is an increasing participation. I'll just talk a little about iCreate, and with that I will end and open to questions if there are any, otherwise we can move out and continue with the questions. So this is the organization I represent, International Center for Entrepreneurship and Technology. It happens to be India's oldest standalone incubator. An exclusive autonomous national institute with a global outlook, which was established in 2012 with the premise that India needs entrepreneurial capital and a nation is shaped by what talented people choose to do. So this is the basic premise. That's how it was set up. We're on the outskirts of Ahmedabad. All such numbers look good on a slide. These are milestones that iCreate has accomplished in its 12-year-odd history. More than 500 startups projects financially supported, more than I think the actual number in terms of ideas evaluated is close to 15,000 patents. The top startups have done, the real top startups, just like anywhere else, have done well, attracted a lot of market capitalization. We are across domains, we are across industries. Okay. So here my key point is, I was here and when Arun and Publish India invited, the idea was more to talk about startups in general than about iCreate in specific. However, remember there are 1,000 plus incubators. I'm not saying we're perfect. We're just better than most out there. Are we the best? We may not be in every segment. It doesn't matter. You don't have to come to us, but go to an incubator. iCreate does have an electric vehicle center of excellence. I personally believe there's a lot of scope for improvement, but market and industry tells me it is the best in the country within the incubators. Okay. We have had nationwide innovation contests. The third one happened December last year. and attracted 2,700 applications on different ideas at different stages of the life cycle of from an idea to almost TRL 8. And 31 of these were actively supported through funding, 28 completed product development, about 17 or 18 are right now at the commercialization stage. So if you look at 2,700 to 1,800, 4,500 applicants coming down to 14, 17, 18, startup is a tough world. It's not easy to, everything doesn't work. Okay. But as an industry, you can play your part both in benefiting and in helping some of those 17, 18. Let me just play a small video on iCreate, and I think this will be my end. Very nice. So I'll have to go back. Yeah. Can I? Just, it's in the folder, just play it separately.
Okay.
There's a video. No, no, don't play it from the presentation. Open the folder view.
I'll just close this.
Hey, print right now. It's, yeah. Just play this. You have to make it full screen and the sound here. Just rewind it. So I chose the video because it will be a lot easier. Like most videos, it covers a lot about the organization. If I have to talk about it, it'll take a lot longer. So that's the primary reason. Let them just set it up.
iCreate जैसे संस्थान इनोवेशन इकोसिस्टम को बढ़ाने में बहुत महत्वपूर्ण रोल प्ले कर रहे हैं।
Thank you. You close that. Close.
I think I can do.
No, this is my obvious biggest discomfort with a Mac versus a Windows laptop?
Yeah, it's your.
Do I have to eject or just pull out?
Yes,
Sorry.
Thank you so much, sir. That was really interesting and insightful. I would now like to invite Mr. Ashwani Jotshi to felicitate Mr. Madan. Thank you so much, ladies and gentlemen, for showing the patience that for today. I would like to request all the delegates to take a few moments to fill out the feedback form available on your desk. Your feedback is invaluable in helping us improve our future editions of the International Automotive Manufacturing Summit. As we near the end of our summit, it's time to acknowledge the collective efforts that have made today possible. To formally conclude today's event and express our gratitude, I would like to invite Mr. Dhiraj Bhalerao, the esteemed director and publisher of Efficient Manufacturing magazine, to the stage.
I think it's the last presentation. Okay. I have a quick people to thank. On behalf of Efficient Manufacturing magazine, I would like to thank ARAI for the invaluable support and collaboration. Heartfelt thanks to iCreate and Star Engineers. Your partnership and dedication have significantly enriched our event. All our distinguished speakers, thank you for sharing your knowledge, your expertise, and your perspectives. We also like to thank our hospitality partner, Residency Club. Special thanks to Pixion, our digital partner. Your expertise in managing our digital needs seamlessly allowed us to deliver a top-notch experience. Lastly, also I would like to thank Ashwani ji for his association with our summit, which has been a cornerstone to our success. Thank you once again. Thank you.
Thank you, sir. I would like to thank all of you for being such a patient audience today. Ladies and gentlemen, this concludes our formal proceedings. I hope you found the sessions insightful and inspiring. As we continue to foster connections and discussions, we invite you to join us for networking lunch, which is now served in the dining area. Enjoy the meal and take this opportunity to network with the fellow industry professionals. Thank you once again for your participation and engagement, and we look forward for your participation for our upcoming events. Thank you so much.